Hello there, and welcome to Life Beyond Seen, where curiosity gets cozy, the world grows quieter, and strange places on the map become a little easier to understand before sleep. Tonight, we are travelling to a cold, remote, and often overlooked corner of the Pacific, a place with ice that can crush steel, fog that can swallow a coastline, storms that can turn a working deck into a skating rink, and waters so difficult that even experienced sailors treat them with deep respect. This is the Sea of Okhotsk, a name that sounds almost like something whispered from the back of an old atlas, tucked away above Japan, beside Russia, below the wild Kamchatka Peninsula, and behind the long broken chain of the Kuril Islands. It is not as famous as the North Atlantic. It does not appear in ordinary conversation like the Mediterranean or the Caribbean. It does not have the easy brightness of a tropical sea, with postcards, umbrellas, and someone losing a sandal in warm sand. The Sea of Okhotsk belongs to another kind of story. It is colder, heavier, quieter, and far less interested in making anyone comfortable. It is the kind of sea that seems to say, very politely, do check your equipment before entering. And then, perhaps it adds, actually check it twice. Before we move farther into its ice, storms, ships, animals and hazards, I would love to know where in the world you're listening from tonight. Are you near an ocean, a lake, a river, or are you tucked safely inland, far from anything that smells of salt and cold wind? And what is the weather doing outside your window right now? Is it raining softly against the glass, snowing in the streetlight, or perfectly still, the sort of stillness that makes even a kettle sound dramatic? It feels fitting to ask, because this place we are visiting is ruled by weather. Not the pleasant kind that decides whether you need a light jacket, but the serious kind, the kind that shapes coastlines, delays ships, traps ice, hides islands, and reminds every human plan that nature has not signed the schedule. The Sea of Okhotsk lies in the northwest Pacific, but it is not an open, easy stretch of ocean. It is partly enclosed, almost held in place by land and islands. To its west and north are the cold edges of Russia's Far East. To the east stands the Kamchatka Peninsula, a long volcanic arm reaching down toward the Pacific. To the south are the Kuril Islands, a scattered chain of rugged islands that separate the sea from the wider ocean. And to the southwest sits the large island of Sakhalin, with Japan's Hokkaido not far beyond. On a map it looks like a huge basin with several narrow doors. Through those doors water moves in and out, weather presses in from the continent and the Pacific, and ice forms, breaks, drifts, piles up and melts with the seasons. It may be tempting to imagine a sea as one simple thing, a flat blue shape between coastlines. Maps encourage that mistake. They colour the water neatly, print a label across it, and leave out the unpleasant details such as freezing spray on a vessel's railings, sudden fog near the horizon, shallow shelves, strong currents, and waves that arrive in no mood for discussion. The Sea of Okhotsk is not just a blue shape. It is a working system of cold air, moving water, sea ice, fisheries, volcanic islands, river inflow, deep basins, continental shelves, shipping lanes, and weather patterns that can change the mood of a voyage very quickly. If ordinary seas can be compared to roads, then this one is a mountain pass in winter, with poor visibility, sharp turns, and a sign at the entrance that probably says, "Are you absolutely sure?" One reason the Sea of Okhotsk feels so severe is that it is one of the coldest seas in East Asia. In winter, large parts of it behave more like the Arctic than what many people imagine when they hear the word Pacific. Cold air pours out from Siberia and the Russian Far East, moving over the water and pulling heat from the surface. The sea begins to freeze, not all at once and not evenly, but in sheets, patches, belts, and drifting fields. Ice forms near the northern and western coasts first, then spreads, thickens, and moves under the pressure of wind and currents. For a ship, this is not a simple white covering. It is a moving obstacle field. Ice can block harbours, slow engines, damage hulls, trap smaller vessels, and turn an already difficult rescue into something far more complicated. Sea ice has its own character. It creaks, it grinds, it rafts up into ridges, it opens into dark leads, then closes again. From a distance, ice can look peaceful, almost soft, like a frozen quilt laid across the water. Up close it can be jagged, heavy, and indifferent. It does not need to be thick across the whole sea to cause trouble. Even broken ice can become dangerous when wind pushes it together or when waves lift and drop it against a hull. Imagine trying to walk through a room while all the furniture is slowly sliding around, except the furniture weighs tons, has sharp edges, and the room is also very cold. That is not a perfect comparison, but it is close enough to make most sensible people reach for a blanket and stay on land. Then there is the fog. The Sea of Okhotsk is known for dense fog, especially in the warmer months when moist air meets cold water. Fog is not dramatic in the same way as a storm. It does not roar. It does not throw spray across a deck or hammer windows. It simply removes the world. A headland disappears. A nearby ship becomes a sound before it becomes a shape. The horizon goes missing, which is rude, really, because the horizon has one job. In thick fog, distance becomes difficult to judge. Navigation instruments help, of course, and modern ships are far better equipped than those of the past. But fog still changes the feeling of a place. It makes everything slower, more cautious, more uncertain. It turns the sea into a grey room with no walls. Fog can also make danger feel strangely quiet. A storm announces itself. Fog just arrives and sits down. For fishermen, cargo crews, coast guards, and anyone moving through narrow passages or around island chains, this matters. The Sea of Okhotsk is bordered by complex coasts, remote settlements, and long distances from major ports. Help may not be close. Weather reports may be good, but the sea itself remains the final editor. And when fog, ice, wind, and current work together, even routine movement becomes something that demands attention. It is one thing to be delayed on a train and sigh at the clock. It is another thing to be delayed by ice with a storm system forming and no cafe carriage in sight. The weather here is not difficult by accident. Geography helps make it so. The surrounding land cools sharply in winter, while the open Pacific still sends in moisture and energy. The result is a region where pressure systems can deepen, winds can strengthen, and cold air can sweep across wide water with little to slow it down. In winter, waves, snow, and freezing spray can make life at sea exhausting. Freezing spray is exactly what it sounds like, and somehow even less pleasant. Water thrown into the air by wind and waves freezes when it lands on a ship. It coats railings, decks, gear, antennas, and sometimes lifeboats. Bit by bit, weight builds up. The vessel grows top-heavy. Crew members have to remove ice in brutal conditions, often while the sea is still moving beneath them. It is one of those maritime problems that sounds manageable until you imagine doing it at night, in high wind, on a deck that is trying very hard to become a skating rink, and this is only the surface story. Below the water, the Sea of Okhotsk is also shaped by depth, currents, and the narrow passages between the Kuril Islands. Those islands form a broken wall between the sea and the Pacific. Water moves through the gaps, and where water is forced through narrow places, currents can become strong and complicated. Add wind, tide, temperature differences, and rough bottom terrain, and you get a sea that is not always predictable in the way a person would prefer before bedtime. Mariners are used to complexity, of course. They work with charts, forecasts, radar, sonar, and experience. But experience in places like this often includes a healthy respect for how quickly ordinary can become serious. The Kuril Islands add another kind of danger, one that does not come from weather at all. They sit along one of the most active tectonic zones on Earth, part of the great ring of seismic and volcanic activity around the Pacific. Earthquakes happen in this region. Volcanoes rise from the islands. Tsunamis have been generated along nearby subduction zones. That does not mean every day is a disaster waiting politely in the hallway, but it does mean the region carries geological risk as part of its character. The floor beneath and near the sea is not still in the deep time sense. Plates move, stress builds, land rises, sinks and shakes. A sea can be dangerous from above, from its surface and from far below, which feels a little excessive, but the planet has never been known for asking permission before doing geology. For people who live and work around it, the Sea of Okhotsk is not just dangerous. It is useful, rich, and necessary. Its waters support major fisheries. Fish, crab, and other marine resources have drawn people into these cold waters for generations. There is also oil and gas development around Sakhalin, which brings industry, equipment, ships, platforms, and difficult decisions about risk and reward. The same sea that threatens human plans also feeds towns, supports livelihoods, powers economies, and holds ecosystems of remarkable productivity. That is one reason it deserves more attention. It is not simply a remote hazard zone. It is a place where human need meets harsh nature in a very direct way. People go there because there is work to do. The sea does not become safer just because the work is important. This contrast is part of what makes the Sea of Okhotsk so interesting. It is both hidden and significant. Many people could point to the Pacific on a map, but far fewer could find this sea quickly. Yet it influences climate, wildlife, fisheries, shipping, and regional economies. It forms sea ice at latitudes where people might not expect so much ice. It provides habitat for seals, whales, seabirds, plankton, fish, crabs, and other life adapted to cold water and seasonal change. It touches Russia and sits near Japan, linking natural history with human history, trade, conflict, exploration, and survival. It is not famous in the ordinary tourist sense, but fame is not the same as importance. Some places do not need to be famous. They're too busy being difficult. The phrase "most dangerous sea you've never heard of" is, of course, a little dramatic. Titles sometimes put on a coat and stand in a spotlight, but in this case, the drama has somewhere solid to stand. The danger is not one single monster wave or one famous storm. It is the combination. Seasonal sea ice, dense fog, severe winter weather, remote coastlines, strong currents, volcanic islands, earthquake and tsunami risk, heavy industry, fishing pressure, limited rescue access in some areas, and long stretches where the map looks empty because in human terms it nearly is. Many seas are dangerous in one way. The Sea of Okhotsk collects several dangers, stacks them neatly, and then adds cold. Cold changes everything. Metal behaves differently. Engines complain. Ropes stiffen. Hands lose feeling. Small mistakes grow larger. A wet glove becomes a problem. A delay becomes a risk. A mechanical failure becomes urgent. Even the human mind works differently when tired, cold, and alert for too long. That is one reason cold water seas have a seriousness to them that warm seas often do not. Warm water can still be deadly, of course. Tropical storms are not exactly known for their hospitality. But cold adds a time limit to almost everything. If someone falls overboard in freezing water, the clock begins at once, and it does not care how brave, skilled, or well-intentioned anyone is. And yet, despite all of this, the Sea of Okhotsk can be beautiful. Not in a soft postcard way, though there are moments of that too. Its beauty is sharper and more restrained. Ice along a coast at low light, mountains rising behind fog, a whale surfacing in cold water, a fishing vessel moving through grey morning, birds following the wind over a sea that looks almost metallic. The kind of beauty that does not invite you to relax completely, but does make you look closely. It is possible to be calm and cautious at the same time. In fact, in places like this, that may be the wisest mood available. So tonight, we will not rush through it. We will take our time with this hidden sea. We will begin with where it is, because every dangerous place becomes more understandable once you can place it properly on the map. We will look at the ice that forms across it, the fog that hides it, the storms that move over it, and the earthquakes that shake the edges of its basin. We will drift through stories of ships and isolation, look beneath the frozen surface at the life that survives there, and consider why humans keep returning to waters that make so many demands. Not because we are foolish, though sometimes we are impressively capable of that, but because seas like this offer food, passage, fuel, knowledge and challenge. If you find this slow journey soothing, interesting, or simply useful company while the day begins to loosen its grip, I would be grateful if you gave the video a like and subscribed. It helps this quiet corner of curiosity reach more people who enjoy learning without being shouted at by the internet, which is a small mercy in modern life. And if you know someone who loves maps, cold places, strange coastlines, ships, storms, or the kind of geography that makes you lean closer and say, wait, where exactly is that? Then perhaps share this with them as well. For now, settle in. Let your shoulders drop a little. Let the room around you become simple. No need to brace against the wind. No need to stand on an icy deck or scan a grey horizon for land. We're only visiting from the safe side of the story, with the lights low and the sea held at a comfortable distance. But out there, north of Japan and east of Siberia, the Sea of Okhotsk is still doing what it has always done. Freezing, thawing, fogging over, feeding life, testing ships, and waiting quietly at the edge of the map. To understand why this sea has earned such a hard reputation, we first need to find it properly, not just as a name printed across blue paper, but as a real place shaped by land, weather, ice and distance. To understand the Sea of Okhotsk, the first task is simply finding it. That may sound easy enough. After all, it is not small. It covers a vast part of the Northwest Pacific, larger than many countries, larger than a person would ever guess from how rarely its name comes up in ordinary conversation. And yet it has a strange way of hiding in plain sight. It sits on maps like a cold blue chamber between Russia and Japan, bordered by some of the most rugged coastlines in the world, but it is often skipped over by the eye. People know the Pacific, they know Japan, they may know Siberia, Kamchatka, or the Kuril Islands if they enjoy geography, volcanoes, or looking at maps when they are supposed to be doing something else. But the sea itself often remains unnamed in the mind, a wide northern basin that many people have seen without really noticing. It lies above Japan, east of mainland Russia, west of the Kamchatka Peninsula, and behind the long, uneven chain of the Kuril Islands. Sakhalin Island forms much of its western and southwestern edge, while Hokkaido, the northernmost of Japan's main islands, sits near its southern doorway. The Kamchatka Peninsula forms a great eastern wall, stretching down like a remote arm of mountains, volcanoes, forests and cold coast. The Kuril Islands run from Kamchatka toward Hokkaido, not as one solid barrier, but as a broken line of volcanic islands and narrow straits. Through those gaps, water from the open Pacific enters and leaves. On the map, the whole arrangement makes the Sea of Okhotsk look partly closed off, as if the Pacific tried to place a private room behind a row of islands and cliffs. That partial enclosure matters. It gives the sea its shape, its mood, and many of its hazards. An open ocean can spread its energy across enormous distances. A partly enclosed sea has borders that interfere, redirect, and trap. Winds sweep down from the cold interior of Asia. Currents move around islands and through straits. Rivers bring fresh water. Ice forms in some regions, drifts into others, and becomes part of the seasonal machinery of the place. The Sea of Okhotsk is not a simple bowl of water. It is a complicated meeting place where the continent, the Pacific, the Arctic like winter, and the volcanic edge of the Earth all come close together. Its size is part of the surprise. This is not a narrow coastal bay, or a small northern inlet. The Sea of Okhotsk covers around 1.58 million square kilometres, which is difficult to picture because numbers that large tend to turn into mist in the brain. It is roughly the size of Mongolia, or more than twice the size of Texas, depending on which comparison happens to feel less enormous. It has an average depth of about 859 meters, but in places it drops much deeper, reaching more than 3,300 meters. So even though it is partly enclosed, it is still a true sea, with broad shelves, deep basins, powerful water movement, and enough room for storms to build real strength. It is not a pond with a severe attitude, it is a major northern sea, and it behaves like one. The name comes from Okhotsk, a settlement on the northern coast that became important in Russia's expansion toward the Pacific. Okhotsk itself is remote even now. In earlier centuries, it was one of those places that stood at the far edge of a difficult journey where roads were poor, rivers were long, winters were hard, and distance was not an inconvenience but a serious obstacle. The sea took its name from that region, and the name still carries some of that feeling. Okhotsk does not sound warm or easy. It sounds like a place where boots matter, where a door should be closed properly behind you, and where the weather has strong opinions. For Russia, the Sea of Okhotsk has long been more than a remote body of water. It was one of the first Pacific regions reached by Russian explorers moving across Siberia toward the east. Long before modern ports, satellite navigation, and weather models, getting to this sea meant crossing some of the most demanding land on Earth. Rivers, forests, mountains, cold, hunger, and enormous distances stood between European Russia and the Pacific coast. When Russian explorers and traders finally reached the Okhotsk coast, they were not arriving at an easy new world. They were arriving at another hard frontier, this time made of salt water, ice, fog, and storms. This helps explain why the Sea of Okhotsk feels hidden. It is not hidden because no one has ever used it. People have fished it, crossed it, studied it, fought near it, mapped it, and built industries around it. It is hidden because it sits at the edge of several worlds rather than at the centre of one. It is part of Russia's Far East, far from Moscow and St. Petersburg. It is close to Japan, but not part of the warm, heavily travelled seas that many people associate with Japanese coasts. It belongs to the Pacific, but it is tucked behind islands and often frozen in winter. It is connected to global systems, but it feels distant from the crowded mental map most of us carry around. It is important, but not familiar. Maps can make this distance feel smaller than it is. A finger can slide from Tokyo to Hokkaido, from Hokkaido to Sakhalin, from Sakhalin to the wide grey blue of the Sea of Okhotsk in a second. Real distance is less polite. The northern coast is remote. Much of the shoreline is sparsely populated. Some places are reachable only by air or sea. Roads may be limited or seasonal. Weather can cut off movement. The sea links settlements, ports, fishing grounds and industrial zones, but it also separates them. It is both a road and a barrier, which is a common trick of seas and a frequent source of inconvenience for humans. Along its western side lies Sakhalin, a long island with a complicated history. It has been claimed, settled, contested, divided, developed, and watched by empires and states over time. Its eastern coast faces the Sea of Okhotsk directly, exposed to cold water, sea ice, fog, and storms. Oil and gas projects around Sakhalin have made the region economically important, but the same geography that makes offshore resources possible also makes operations difficult. A platform or vessel working in these waters is not operating in a mild environment. It must account for ice, waves, wind, distance, and long periods of severe weather. Nature does not give a discount because the equipment is expensive. To the east, Kamchatka rises like one of the great remote peninsulas of the world. It is famous among geologists and volcano watchers, though not exactly famous in the way beach resorts are famous. Kamchatka is a land of active volcanoes, earthquakes, rivers, bears, snow and long coastlines. Its western side faces the Sea of Okhotsk, while its eastern side opens toward the wider Pacific. The peninsula helps enclose the sea, but it also helps create a dramatic contrast. On one side, the partly enclosed basin, on the other, the open ocean, and the deep trenches of the Pacific margin. A sailor near Kamchatka is never far from the feeling that the planet is still under construction. South of Kamchatka, the Kuril Islands form one of the most important boundaries of the sea. They are volcanic, exposed, and scattered across a stormy region where the Pacific and the Sea of Okhotsk exchange water through deep and shallow passages. Some islands are inhabited, many are remote, and all of them stand in a zone where weather and geology are both active. The straits between the islands are not just empty gaps, they are moving corridors. Currents, tides, wind and seafloor shape the way water passes through them. For ships, these passages can be useful, necessary and dangerous at the same time. A gap on a map may look like an invitation. At sea, it may behave more like a negotiation. At the southern edge, Hokkaido gives the Sea of Okhotsk its most accessible face for many travellers. Japan's northern island has towns, ports, railways, roads, and places where drift ice can be seen in winter. Along the Okhotsk coast of Hokkaido, sea ice sometimes arrives from the north, a seasonal visitor that turns the coastline into one of the few places at relatively low latitude where ordinary people can witness drifting sea ice without travelling to the high Arctic. This is one reason the sea is scientifically interesting as well as visually striking. It creates ice far south, compared with many other ice-forming seas, due to the special combination of cold air, fresh water, influence, circulation, and geography. The Amur River also matters in this story. It flows into the region near the sea's western side through the Amur estuary and contributes fresh water that helps influence surface salinity. Salinity is not the sort of word that usually makes people sit up in excitement, unless they are oceanographers, in which case it may be the beginning of a very lively evening. But salinity matters because it affects freezing, water density, layering and circulation. Fresher surface water can freeze more readily than saltier water, and when sea ice forms, salt is rejected into the water below, helping produce cold, dense water. That dense water can sink and move, carrying oxygen and nutrients into the wider system. A hidden sea, it turns out, can have effects that travel well beyond what most people see from shore. This is one of the quiet truths of geography. Places that look remote are not necessarily isolated in their influence. The Sea of Okhotsk helps form dense water that contributes to circulation in the North Pacific. Its seasonal ice affects marine ecosystems. Its fisheries feed people and economies. Its weather affects ships, ports, and coastal communities. Its earthquakes can generate hazards far from the point where the seafloor moves. A person may never hear its name in school, may never see it in a travel advert, may never meet anyone who has crossed it, and still live in a world partly shaped by what happens there. The map has many rooms like this. The famous rooms get the photographs. The important rooms keep working quietly. Because it sits so far north and so close to the Asian continent, the Sea of Okhotsk has an extreme seasonal personality. In summer, fog and cool water dominate many areas. In winter, ice spreads across much of the sea, especially in the north and west. This makes it very different from the warmer seas south of Japan or from the open Pacific in lower latitudes. A ship moving from one region to another can pass not only from one sea to another, but from one set of rules to another. Warm currents, cold currents, sea ice, fog belts, and storm tracks all create boundaries that do not show clearly on simple maps. The coastlines are visible. The invisible conditions are often more important. If you look closely at the map, the Sea of Okhotsk also shows the importance of thresholds. It connects to the Sea of Japan through narrow northern and southern passages around Sakhalin. It connects to the Pacific through the Kuril Straits. These connections are not wide open doors. They are controlled spaces. Water must move through them, and that movement shapes the sea's circulation. In the north, conditions are colder and shallower in many areas. In the central and southern parts, deeper basins and open passages create different conditions. This is one reason a single label, Sea of Okhotsk, can hide many local realities. The same sea can be ice-choked in one area, fog-bound in another, deep and rough in another, and relatively calm somewhere else for a short while, just long enough to make someone overconfident. Overconfidence is not a useful trait here. The geography itself discourages it. The coasts are long, the distance is large, and the weather windows often narrow. Remote seas do not only test ships when conditions are bad, they also test planning when conditions are good, because good conditions can end. The nearest safe harbour may not be close. The nearest rescue asset may have to deal with the same weather that created the emergency. Communication is better now than it once was, but the sea has not become smaller. A satellite phone does not move a storm out of the way. A modern chart does not make ice less solid. Technology helps enormously, but it does not remove the basic fact that this is a hard place to work. That hardness has shaped human activity around the sea. Fishing communities, port towns, naval planners, scientists, oil workers, and coastguards all approach it with practical attention. They do not need dramatic language to understand it. The sea explains itself through delays, damage, fuel calculations, ice reports, and weather warnings. It also explains itself through abundance. Cold, nutrient-rich waters can support productive marine life. Fish and crab do not care whether a place is comfortable for humans. In fact, some of the best fishing grounds on Earth are in waters that are cold, rough, and thoroughly unpleasant for anyone hoping to wear linen. The Sea of Okhotsk is one of those places where biological richness and human discomfort live side by side. Its hidden quality also comes from politics and language. Many of the places around it are Russian, and for much of the modern era, especially during the Soviet period, access to information, travel, and military regions was limited. The sea has been important for naval strategy, fishing, resource development, and regional control. It is not just a natural feature but a geopolitical space. Some seas become famous because they are crossed by tourists, cruise ships, and trade routes that connect major global cities. Others remain less familiar because they are bordered by restricted areas, sparse settlements, harsh coastlines, or states that do not turn them into public postcards. The Sea of Okhotsk belongs more to charts, patrols, fishing fleets, scientific papers, and weather reports than to casual vacation brochures. There is also something about its position that makes it feel like the end of the map, even though maps do not really have ends. Look at Northeast Asia, and your eye moves across Siberia, one of the largest land regions on Earth, until the continent frays into peninsulas, islands, and seas. The Sea of Okhotsk sits in that transition, where the land gives way to the Pacific through broken edges. It is not the centre of a familiar route. It is a place you arrive at after crossing mental distance. Even the names around it carry that feeling. Kamchatka, Sakhalin, Kuril, Magadan, Okhotsk. They sound remote to many listeners because for most of the world they are remote, not imaginary. Not empty, just far from the usual routes of attention. And still, the sea is full of movement. Ice moves, fish move, storms move, currents move, ships move when they can. Birds migrate along coasts and islands. Whales travel through cold feeding grounds. Human borders may appear firm on maps, but the sea itself is never still. It circulates through straits, freezes and opens, receives rivers, exchanges water with the Pacific, and carries life through its seasons. This is why a hidden sea can be difficult to describe in one mood. It can be silent under ice, loud under wind, grey under fog, bright under low sun, industrial near ports, wild near cliffs, and biologically crowded beneath a surface that looks empty. For a sleep-friendly journey, there is a useful comfort in starting with geography. It gives the mind something solid to hold. Here is Sakhalin, here is Kamchatka, here are the Kurils, here is Hokkaido, here is the Russian mainland. Between them lies the Sea of Okhotsk, large, cold, partly enclosed and often overlooked, Once those pieces are in place, the rest of the story becomes clearer. The danger does not come from mystery alone. It comes from understandable facts arranged in a difficult way. Cold continental air, narrow straits, seasonal ice, deep water, remote coasts, active geology, heavy working seas. These are not vague threats. They are concrete conditions, and they can be read from the map if one knows what to look for. Imagine standing safely in a warm room with a large physical atlas open on a table. No wind in your face, no spray freezing on your coat, no need to check a radar screen. Your finger traces the coast north of Japan, passes Hokkaido, crosses towards Sakhalin, moves along the Russian mainland, then turns east toward Kamchatka. The space inside that rough frame is the Sea of Okhotsk. At first, it may seem like just another label. Then, as the eye adjusts, the place becomes more specific. The islands become gates, the peninsula becomes a wall, the northern coast becomes a source of cold, the southern edge becomes a threshold to Japan. The open Pacific waits outside the Kurils, while inside the sea gathers ice, fog, life, and danger. That is the first step in understanding why this sea has such a hard reputation. It is not dangerous because it is unknown. It is unknown to many people because it is distant, severe, and rarely packaged into easy stories. The people who work there know it well. Scientists know it through ice charts, water samples, satellite data, current measurements, and ecological studies. Mariners know it through forecasts, routes, engine strain, and the slow discipline of caution. Coastal communities know it through food, weather, income, and risk. The rest of us may only be meeting it now from the quiet safety of a narrated journey, which is probably the most comfortable way to begin. Once the sea is placed on the map, the next thing to understand is what happens when the seasons close in. The Sea of Okhotsk is not content merely to be remote. In winter, it changes form. Water becomes ice. Coastlines are blocked. The surface hardens, breaks, drifts, and reforms. Fog waits for warmer months, but cold is the older ruler here, and ice is one of the main reasons this sea can be so dangerous. To see how a sea becomes a field of moving white, we need to follow the cold air southward and watch what it does to the water. When winter settles over the Sea of Okhotsk, it does not simply cool the surface and leave the rest alone. It changes the identity of the place. The open water begins to stiffen, the wind sharpens, the sky lowers, the horizon turns pale, then uncertain, then at times completely lost behind snow, mist, and drifting ice. A sea that was already remote becomes something even more difficult to cross because the surface itself starts to become a moving barrier. Water, that most restless of things, begins to form edges. This is one of the details that makes the Sea of Okhotsk so unusual. It sits far south of the high Arctic, and yet every winter sea ice forms across large parts of it. Not a decorative frost along the shore, not a thin overnight skin that melts with breakfast, but wide seasonal ice that can be seen from satellites, spreading across the basin in white and grey patterns. It is one of the lowest latitude places in the northern hemisphere where sea ice forms regularly, which is a polite scientific way of saying that the sea is far colder and stranger than its position on the map might suggest. If you looked only at latitude, you might expect difficult winters, yes, but not such an enormous icy transformation. The Sea of Okhotsk, however, has never been especially interested in meeting casual expectations. The process begins with cold air. In winter, the land around the sea, especially Siberia and the Russian Far East, loses heat quickly. Land cools faster than water, and the air above it becomes bitterly cold. That cold air then pours out over the sea, pushed by winds that move from the continent toward the water. When this freezing air crosses the surface, it draws heat upward and away. The sea resists at first, because seawater does not freeze as easily as fresh water, and because the ocean stores an enormous amount of heat. But if the cold keeps coming, if the nights are long enough and the winds are persistent enough, the surface begins to give in. Sea ice does not usually begin as one neat sheet. It starts in small forms, often delicate at first. Tiny ice crystals appear in the upper water, creating a slushy texture sometimes called frazzle ice. The surface may look greasy, as if someone has spread a faint skin of oil across the waves, though of course it is ice forming in its earlier stage. Then the crystals gather. Small discs of ice may bump together, their raised edges making them look like floating pancakes. Pancake ice is a real term, and it is one of those rare scientific names that sounds as if someone named it before lunch. These pieces can grow, freeze together, break apart, pile up, and eventually create larger fields. Near the coast, where the water is shallower and the influence of rivers can lower salinity, ice can form more readily. The Amur River system, along with other sources of fresh water, helps freshen parts of the sea's surface. That matters because fresher water freezes at a slightly higher temperature than saltier water. It also changes the layering of the water, allowing cold surface layers to remain in place long enough to freeze. So the winter sea is not just responding to cold air, it is responding to a whole arrangement of river water, salt, wind, depth, geography, and circulation. The result is seasonal ice that can spread across vast areas, especially in the northern and western parts of the sea. From far above, the ice can look calm. Satellite images show broad white fields, twisting filaments, dark cracks, and cloud-like swirls. It can be beautiful in the way that remote natural systems often are when viewed from a safe altitude. The danger is easier to miss from there. On the water, ice is not a picture. It is a force. It drifts with wind and current. It presses against coastlines. It blocks passages. It surrounds vessels. It can open suddenly, revealing black water, then close again under pressure. A ship moving through it has to think not only about where the ice is now, but where it may be by the time the ship reaches it. Ice is not a wall. A wall at least has the decency to stay where you left it. For mariners, sea ice creates several kinds of trouble at once. It can slow progress until a schedule becomes more of a suggestion than a plan. It can damage hulls, rudders, propellers, and equipment. It can hide smaller hazards. It can make it difficult to maneuver, especially for vessels not built for ice. It can trap fishing boats, or force larger ships to wait for icebreaker support. Even modern vessels with good charts, satellite data, and communication equipment have to respect the basic fact that ice is heavy, mobile, and sometimes stronger than human optimism. A captain may know the route perfectly, and still have to admit that the sea has rearranged the furniture overnight. The ice also affects ports and coastal communities. Harbours can become difficult or impossible to use without ice breaking. Supply routes may be disrupted. Fishing seasons and shipping windows depend on conditions that vary from year to year. For people who live near the Sea of Okhotsk, ice is not a rare spectacle. It is part of the calendar, part of the economy, part of planning, and part of the local sense of time. Where some communities mark winter with frost on windows and a brief argument with a snow shovel, places around this sea may mark it with ice charts, harbour conditions, and the slow question of when the water will open again. On Japan's northern island of Hokkaido, the arrival of drift ice along the Okhotsk coast has become a seasonal event. Visitors sometimes come to see the ice from shore or from special sightseeing vessels, safely turning a severe natural process into something observable and even charming. There is nothing wrong with that. Humans are very good at making beauty out of things that would be alarming under less controlled circumstances. A thunderstorm viewed from a warm room is atmospheric. A thunderstorm viewed from a small boat is a conversation with your life choices. Drift ice is similar. From land, it can look like a quiet white plane meeting the coast. From a working vessel, it may look more like a list of immediate concerns. The white surface also changes the sea below. When sea ice forms, salt is pushed out of the ice and into the water underneath. This makes the water below colder and saltier, and therefore denser. Dense water can sink and move along the seafloor, or through deeper layers, carrying oxygen into parts of the North Pacific system. In that way, the Sea of Okhotsk is not just freezing for its own local drama. Its winter ice helps drive water movement that matters beyond the basin. Cold places often have this hidden influence. They may seem empty or still, but they are busy producing changes that travel. Ice also influences life. The underside of sea ice can host algae and tiny organisms. When spring-light returns and the ice begins to melt, nutrients and changing conditions can help support plankton blooms. Those plankton feed larger organisms, which feed fish, which feed seabirds, seals, whales, and people. The frozen season is not a pause button for the ecosystem, it is part of its rhythm. Life adapts to the timing of ice formation and retreat. Some animals depend on ice as a platform, shelter, hunting ground, or marker of seasonal change. Others depend on the productivity that follows the melt. What looks like a silent white lid from above is connected to a great deal of activity beneath. Still, silence is a useful word here, as long as we do not take it too literally. Ice makes sounds. It cracks, rubs, squeals, and groans. Wind moves over it. Waves lift it. Pressure ridges form when sheets push together. Snow falls across it and softens the surface. But compared with open water, the ice season can create a strange quietness, especially near coasts and remote bays. The usual visual movement of waves is reduced or hidden. The colours flatten into white, grey and dark blue. Land, sky and sea begin to resemble each other. Distance becomes hard to judge. A shoreline can look close when it is far away, or vanish when it should be plainly visible. In such a place, the mind has fewer markers. The world becomes simpler and more confusing at the same time, which is a very northern trick. Then, when the warmer months arrive and much of the ice retreats, the Sea of Okhotsk changes its disguise rather than becoming easy. The ice loosens, breaks, drifts away and melts. Open water returns. Ships move more freely. Fisheries become active in different ways. But the sea has another habit waiting. Fog. Dense fog is one of the major summer navigation problems in the region, and unlike ice, it does not need to touch a ship to cause trouble. It simply takes away vision. Fog forms when moist air meets cold water. Over the Sea of Okhotsk, the water can remain cold even as the air above it becomes warmer and more humid. When that warmer, moist air passes over the cold surface, it cools. If it cools enough, the water vapour condenses into tiny droplets suspended in the air. The result is fog, sometimes thick enough to reduce visibility dramatically. It is not an exotic process. It happens in many coastal regions. But in the Sea of Okhotsk, the combination of cold water, seasonal patterns, and complex mixing can make fog especially persistent and widespread. There is something unnerving about fog at sea because it removes the ordinary scale of the world. On land, if fog hides the distance, there may still be a road, a fence, a tree, or a very damp dog to remind you where you are. At sea, fog can reduce the world to the vessel itself and a small circle of grey water. Sounds carry strangely. A horn may seem close or far, or both. The slap of water against the hull becomes louder because there is less to look at. Instruments become even more important, but the body still wants to see. Human beings are visual creatures. We like a horizon. We like knowing where the big wet thing ends and the sky begins. Fog looks at this preference and gently says no. Modern navigation has changed the risks of fog, but it has not removed them. Radar, GPS, AIS, electronic charts, weather forecasts, and communication systems all help vessels avoid collisions, find routes, and maintain awareness. But fog still demands slower speeds, sharper watchkeeping, and careful judgment. Small vessels may not be as visible. Equipment can fail or be used poorly. Coastlines, ice remnants, fishing gear, and other traffic can complicate matters. Fog also causes fatigue. It requires attention without offering much information in return. Staring into thick fog is like reading a blank page. and being told there may be a paragraph arriving soon at speed. The Sea of Okhotsk is not only foggy because the water is cold. Tides and currents can help bring colder water upward in some areas, creating patches of particularly cold sea surface. These cold patches can encourage fog when warm and moist air passes over them. Around the Kuril region and other areas of strong mixing, the ocean is not a simple layer cake. Water is stirred, lifted, cooled, and moved in ways that affect the air above it. This is one of those places where oceanography and weather hold hands, whether or not anyone invited them to. The sea surface cools the air becomes fog, the fog changes navigation, and suddenly a process measured by scientists becomes a practical problem for people trying to get from one port to another without bumping into anything large. Fog can be especially deceptive because it often arrives without the violence of bad weather. A vessel may not be in a storm, the sea may not be especially rough, the wind may be manageable, yet the danger increases because the world becomes hidden. Mariners have long treated poor visibility as one of the great quiet hazards. It does not shout. It does not break over the bow. It simply reduces certainty. And at sea, certainty is valuable. Knowing where you are, what is nearby, how fast it's moving, and what the weather is doing next can be the difference between routine caution and emergency. For fishermen, fog adds another layer to already difficult work. Fishing vessels may operate in busy areas, sometimes with gear deployed, sometimes moving slowly, sometimes focused on the work of hauling, sorting, icing, repairing, and watching the weather. Add fog, and the crew must manage both the labour and the invisible surroundings. The Sea of Okhotsk supports rich fisheries, but rich grounds can draw many vessels into the same general areas. Where there are vessels, gear, cold water, fatigue, and poor visibility, there is risk. Fishing is already one of the world's more dangerous occupations. A foggy, cold, remote sea does not improve the safety rating. Fog also changes the emotional experience of the sea. Ice can feel like an enemy with a body. You can see it, measure it, watch it move. Fog is more like uncertainty given weather form. It makes familiar places unfamiliar. It makes nearby land vanish. It can turn a known route into a slow act of trust in instruments and training. A lighthouse in fog becomes more sound than sight. A buoy becomes a signal before it becomes a shape. The sea narrows around the listener. That can be strangely calming from the safety of imagination, but for someone responsible for a vessel, it is not restful. It is work. Between ice and fog, the Sea of Okhotsk has a seasonal rhythm that feels almost like a test. In winter, the sea becomes physically blocked and hardened. In summer, when the ice retreats and movement becomes easier, visibility can disappear. In one season, the danger is solid. In another, it is made of droplets. That is a rather efficient arrangement if the goal is to keep humans humble. The sea does not need to be wild every day. It only needs enough difficult days, enough sudden changes, enough hidden hazards to make respect a permanent requirement. There is also the matter of transition seasons. Spring and autumn are not simple pauses between ice and fog. Spring can bring melting ice, broken floes, cold water, unsettled weather, and shifting conditions. Autumn can bring stronger storms, dropping temperatures, and the early signs of freeze-up. A vessel moving through the region must think in terms of timing. Too early, and ice may still be a major issue. Too late, and winter may begin closing the sea again. Even within the same season, conditions can vary across the basin. The northern areas may be locked in ice while southern regions are open. Fog may be dense in one zone and absent in another. Weather may allow a route today and punish the same route tomorrow. The calendar offers guidance, not guarantees. All of this gives the Sea of Okhotsk a particular kind of silence. Not emptiness, because the sea is full of motion and life. Not peace, exactly, because peace suggests safety. It is more like a vast, quiet discipline. Ice teaches patience. Fog teaches caution. Cold teaches preparation. Distance teaches self-reliance. A person looking at this sea from far away may see only a remote northern basin, but anyone who studies it for even a little while begins to notice how many rules it sets. It decides when parts of the surface become passable. It decides when visibility returns. It decides how quickly weather becomes serious. And it does all this without needing to be famous. There is a strange beauty in that. A sea does not need warm beaches to be beautiful. The Sea of Okhotsk's beauty lies in hard edges, pale light, drifting ice, hidden coasts, and the slow return of open water after winter. It lies in the way life persists under the ice, in the way whales and birds follow food through cold seasons, in the way people learn to work with patterns that cannot be controlled. It is not the beauty of ease. It is the beauty of attention, the kind of place that rewards those who look carefully and punishes those who assume too much. So, as the white fields spread in winter and the grey fog rises in summer, the Sea of Okhotsk remains a place of shifting visibility. Sometimes the danger is visible from miles away, a mass of ice across the water. Sometimes it is hidden by a blank wall of fog. Sometimes it is under the hull, in the current, or far off in a pressure system still forming beyond the next weather report. Ice and fog are two of the sea's quietest dangers, but they prepare us for the louder ones. Because once the seasons begin to turn and the atmosphere gathers strength, this same basin can become a place of powerful winds, steep waves, and storms that do not merely pass over the water, but seem to use the sea itself as a kind of workshop. Storms over the Sea of Okhotsk do not need much theatrical help. They already have the right stage. A wide cold basin, long stretches of open water, nearby mountains, narrow island passages, frigid air moving out from the continent, and the restless North Pacific waiting beyond the Kurils. Put all of that together, and the atmosphere has plenty to work with. It can gather moisture, sharpen temperature contrasts, deepen low-pressure systems, and turn a grey horizon into something far more serious than it looked an hour ago. The sea may spend part of the year hidden under ice or fog, but when the wind begins to build, it becomes clear that another kind of danger has been waiting there all along. A storm at sea is never only wind. Wind is the obvious part, the part that pushes against windows, tears at clothing, and makes a person speak in shorter sentences. But at sea, wind becomes waves. It becomes spray. It becomes strain on engines, rigging, nets, cranes, antennas, ice, and human nerves. It becomes a deck that refuses to stay level. It becomes a route that was reasonable on paper and suddenly seems to have developed a personal grudge. The Sea of Okhotsk, with its cold water and severe seasonal weather, gives storms many ways to become unpleasant. The first ingredient is contrast. Storms love contrast. Warm against cold, moist against dry, high pressure against low pressure, stillness against motion. The Sea of Okhotsk lies near one of the great meeting zones of the planet, where the cold Asian continent sits beside the huge North Pacific. In winter, Siberia and the Russian Far East become deeply cold. The ocean, even a cold ocean, holds heat longer than the land. Air masses moving from land to sea meet different temperatures, different moisture, and different surface conditions. The atmosphere responds by rearranging itself, sometimes gently, sometimes not. Low-pressure systems can develop or pass through this broad region, drawing in air and spinning counterclockwise in the northern hemisphere. The stronger the pressure difference, the stronger the wind. This is a simple idea, but simple ideas can become very large when the atmosphere applies them over hundreds of kilometres. A weather map might show curved lines and pressure numbers. A vessel at sea feels those same lines as increasing wind, falling pressure, rising waves, and the quiet realization that the kettle should probably wait. The Sea of Okhotsk is also affected by the storm tracks of the Northwest Pacific. Systems can move out of East Asia, develop over nearby waters, pass near Japan, cross toward the Kuril Islands, or curve into the Northern Pacific. Sometimes storms that began life in warmer latitudes transform into extratropical cyclones, losing their tropical structure but keeping enough energy to produce strong winds and heavy seas. The word extratropical may sound like a holiday package that has gone slightly wrong, but in meteorology it refers to large weather systems outside the tropics, often powered by temperature contrasts rather than warm ocean heat alone. These systems can be enormous, and in the North Pacific they can become very intense. For the Sea of Okhotsk, this means that danger does not always begin locally. A storm may develop elsewhere and move toward the basin, or a low-pressure system may deepen near the region, helped by the clash between cold continental air and moisture from the ocean. Weather in this part of the world is connected to larger patterns. What happens near Japan, the Pacific Storm Track, or the Siberian High can all matter. A sea may look enclosed on a map, but the atmosphere is less respectful of borders. Air simply moves where pressure, temperature and momentum send it, which is impressive, if not always convenient. The surrounding geography adds another layer. The Kamchatka Peninsula, the Kuril Islands, Sakhalin, and the mainland coasts are not smooth, gentle borders. They are rugged, mountainous, volcanic, and complex. Wind moving around land can be funneled through gaps, accelerated along coastlines, or disturbed by terrain. Around island chains and straits, the sea surface may already be complicated by currents and tides. Add strong wind, and the water does not respond like a calm bathtub being stirred with a spoon. Waves can become steep. Cross seas can form where wave trains meet from different directions. Near shore or in shallower areas, waves can shorten and rise. A vessel that was coping in open water may behave very differently as it approaches a narrow passage or a lee shore. A lee shore is one of those phrases that sounds mild until you understand it. It means a coast toward which the wind is blowing. If a vessel loses power or control near such a shore, the wind and waves can push it toward land, rocks, reefs, or surf. In a place with remote coastlines and severe weather, that is not a theoretical concern. The Sea of Okhotsk has long stretches where safe shelter may not be nearby. A storm does not need to sink a ship in the middle of the basin to be dangerous. It can simply remove options. That is one of the quieter ways weather becomes serious. It narrows the choices. Waves in a partly enclosed sea can be especially troublesome because they may be shorter and steeper than long ocean swell. In the open Pacific, swell can travel great distances, with long intervals between crests. In the Sea of Okhotsk, depending on wind direction, fetch, depth, and ice cover, waves may build within the basin and become confused by coastlines and currents. Fetch is the distance over which wind blows across the water. The longer the fetch, the more energy wind can transfer into waves. The Sea of Okhotsk is large enough to give wind room to work, but enclosed enough to reflect and complicate wave patterns. It is the sort of arrangement that allows waves to be both powerful and awkward, which is not a combination anyone on a deck is likely to appreciate. The presence of ice changes storm behaviour and storm danger. When ice covers the surface, it can dampen waves by preventing wind from transferring energy into open water. That sounds helpful, and sometimes it is. Ice can reduce wave growth in covered areas, but this does not make conditions safe. Instead, it changes the form of the danger. Wind can drive ice into pressure ridges, push floes against ships, close leads, or pile ice along coasts. A storm can break ice into smaller pieces or compact it into thicker barriers. At the ice edge, waves and floes interact in rough, unpredictable ways. A vessel near the boundary between open water and ice may deal with waves on one side and moving ice on the other, which is rather like being asked whether you prefer being shoved or squeezed. In recent decades, researchers have also paid attention to how reduced sea ice can allow larger waves to develop in areas that were once more protected by ice cover. Less ice can mean more open water. More open water means more room for wind to build waves. This is not just a local curiosity. It matters for coastal erosion, ship operations, ecosystems and offshore structures. A changing ice cover can change the way storms express themselves across the sea. The danger is not simply that ice exists. Sometimes the danger is also where it does not exist, and how much open water is available for the wind to use. Then there is freezing spray, one of the nastier gifts of cold storms. When strong wind and waves throw seawater into the air, droplets can land on a vessel. If the air is cold enough and the vessel's surfaces are cold enough, those droplets freeze. One droplet is nothing. Thousands and millions of droplets become a coating. The coating thickens. Railings, decks, lifeboats, winches, masts, antennas and fishing gear can all accumulate ice. The vessel becomes heavier, and worse, the ice may build unevenly. If too much weight accumulates high up, the ship's centre of gravity rises. Stability decreases. In severe cases, icing can contribute to capsizing. It is a slow hazard that arrives one frozen splash at a time. Freezing spray is especially difficult because dealing with it may require people to go out on deck in the same conditions that created it. Crew members may have to chip ice away, secure gear, clear equipment, and keep the vessel functional while wind, waves and cold continue to work against them. It is hard physical labour in dangerous circumstances. The deck may be slippery, hands may be stiff, visibility may be poor, the ship may be rolling. And every task takes longer than it should because cold has a special talent for making simple things complicated. A knot becomes stubborn, a latch becomes frozen, a glove becomes wet, a person becomes tired. The sea does not need one dramatic moment if it can simply wear everyone down. Storms also interfere with fishing, and fishing is central to the Sea of Okhotsk. Working vessels may have nets, lines, traps, or processing equipment in use. They may operate near productive grounds, near shelf edges, or in areas where weather can change quickly. A fishing vessel is not just travelling from one point to another. It is working, stopping, turning, hauling, storing, and managing equipment. During a storm, that equipment can become dangerous. Nets can snag, lines can snap, gear can shift, ice can build on crab pots or deck loads. The vessel's movement can make routine tasks hazardous. It is one thing to walk across a floor. It is another to walk across a floor that is wet, icy, tilted, and occasionally tries to throw you into a metal object. Large cargo or industrial vessels face different challenges. They may have stronger hulls, better systems, and more crew, but they also have schedules, cargo, port requirements, and sometimes limited manoeuvrability in rough conditions. Offshore oil and gas operations around Sakhalin must account for severe weather, ice, and remote logistics. Storm planning in such areas is not optional. It is built into engineering, transport, emergency response, and seasonal operations. The sea demands that humans design around it. Not perfectly, because perfection is not available at sea, but carefully. A winter storm over the Sea of Okhotsk can bring multiple hazards at once. Falling temperature, strong winds, snow, reduced visibility, heavy seas, ice movement, freezing spray and mechanical strain can all overlap. Each one would be manageable in some circumstances. Together, they become a system. That is why the phrase bad weather can be too small for what actually happens. Bad weather on land may mean discomfort, delay, and a regrettable umbrella. Bad weather here can mean a chain of problems that feed each other. Strong wind raises waves, waves create spray, spray freezes, ice accumulation affects stability, reduced visibility complicates navigation, fatigue reduces judgment, a mechanical issue becomes harder to fix. The storm does not need to be clever, it only needs to be persistent. The geography of the basin can also create sharp local differences. One part of the sea may be relatively sheltered while another is rough. Winds can be stronger near capes or through straits. A route that looks shorter may pass through worse conditions. A vessel may leave port in acceptable weather and find that the worst conditions are waiting at a narrow passage or exposed shelf. This is why local knowledge remains valuable even in the age of satellites and models. Forecasts can describe the broad picture, but sailors also learn the habits of particular coasts, currents, winds, and anchorages. The sea has local personalities, and some of them are not charming. Storms can affect sea ice in ways that matter after the wind has eased. Ice that was spread thinly can be pushed into thick belts. Open water can appear where ice has been driven away, only to freeze again later. Coastal ice can break up. Drift patterns can change. A storm may leave behind a sea surface that looks different from what charts or previous reports suggested. In icy waters, the aftermath can be as important as the event itself. The wind may pass, but the ice it moved remains. It is rather like having a very messy guest who leaves before cleaning up, except the mess is several kilometres wide and capable of damaging a hull. The storms of the region also have a wider climatic role. The Sea of Okhotsk is involved in the exchange of heat, moisture and momentum between the Asian continent and the Pacific. Storms help move that energy. They mix the upper ocean, break and rearrange ice, drive currents, and influence the formation of dense water. They can affect marine productivity by stirring nutrients upward, or changing the timing and distribution of ice. To a person on a vessel, a storm is immediate and physical. To an oceanographer, it is also part of the machinery of the climate system. Both views are true, one is just much wetter. There is a temptation, when speaking of dangerous seas, to imagine only huge waves and dramatic rescues. Those do happen in maritime history, but danger often lives in less cinematic details. A weather window closes. A crew becomes exhausted. A minor leak becomes harder to manage. A navigation decision is made under pressure. Ice accumulates faster than expected. A port is unreachable. A storm changes direction. Fuel calculations become tighter. Equipment works, then works less well, then needs repair at the worst possible moment. The Sea of Okhotsk does not need to be a constant monster. It is enough that it can stack ordinary maritime problems into extraordinary combinations. And yet storms are not unnatural here. They are part of the sea's normal life. The atmosphere over the northwest Pacific has always moved, deepened, spun and broken apart. Coastlines have always been shaped by wind and wave. Animals have adapted to seasonal violence. Seabirds ride strong air currents. Marine life responds to mixing and nutrient pulses. Ice forms, fractures and reforms. Humans are the ones who arrive with timetables and cargo manifests, which is brave, useful and occasionally optimistic. The sea is not being hostile, it is simply being itself at full volume. From a safe distance, there can be a strange comfort in understanding how storms gather strength. The process is not magic. Cold air, warm water, pressure gradients, wind, waves, fetch, currents, ice, and terrain all contribute. Once you know the ingredients, the danger becomes more concrete. It is still serious, but it is less mysterious. The Sea of Okhotsk is dangerous not because it is cursed, not because it is waiting with bad intentions, but because geography and weather combine there in severe and practical ways. It is a place where physics has plenty of room to demonstrate why humans invented caution. Picture the sea under a winter sky. The light is low. The water, where it is open, is nearly black. White caps tear across the surface. Ice floes shift at the edge of visibility. Snow moves sideways rather than downward, which always feels like weather showing off. A vessel works through the chop, its bow lifting and falling, spray freezing where it lands. The crew is not thinking in grand phrases. They are thinking about speed, heading, ice, engine sound, radar, temperature, fuel, the next watch, and whether a certain piece of equipment is making a new noise or the same annoying old one. This is the real language of storms at sea. Practical, immediate, and full of small decisions. In another season, the scene may be different, but not necessarily gentle. An extratropical system passing through the region may bring strong winds and heavy rain. Fog may sit low before or after the front. Swell may move through the Kurile passages. The air may not be bitterly cold, but visibility and sea state can still make navigation difficult. The Sea of Okhotsk does not confine its seriousness to winter. Winter is simply when it becomes most obviously severe. Storms also remind us why the edges of the sea matter so much. The Kurile Islands are not only a southern boundary, they're a line of openings, hazards, volcanoes, currents, and weather exposure. The same straits that allow water exchange with the Pacific also allow weather systems and waves to connect the enclosed sea with the wider ocean. Around those islands, the sea's physical danger meets another kind of danger beneath the surface of the Earth itself. The water can be rough, the wind can be strong, the fog can be thick, and below all of it, tectonic plates are moving slowly, steadily, and without concern for shipping forecasts. So the story of storms naturally leads us toward the island gates at the edge of the basin. There, the Sea of Okhotsk is not just a cold, foggy, storm-lashed sea. It is part of one of the most active geological margins on the planet, where volcanoes rise from the water, earthquakes shake the seafloor, and the boundary between land and ocean is shaped by forces much older and larger than weather. At the southern and eastern edge of the Sea of Okhotsk, the water does not simply open into the Pacific in one clean, friendly doorway. Instead, it passes through a broken line of islands, straits, rocks, reefs, currents, fog banks, and volcanic slopes. These are the Kurile Islands, stretching from Japan's Hokkaido toward the southern tip of Kamchatka, forming a long, uneven boundary between the enclosed cold sea and the enormous open ocean beyond. If the Sea of Okhotsk is a room at the edge of the Pacific, then the Kuriles are its complicated set of doors. Some are wide, some are narrow, some are deep, some are shallow, and none of them should be crossed without paying attention. On a simple map, the Kurile Islands can look almost delicate, like a dotted line drawn between two larger landmasses. But that is the map being very polite and leaving out most of the work. In reality, these islands are the visible peaks of a much larger and more active system. They are volcanic islands lifted from the sea by processes that begin far below the surface. Some are steep and rugged, some have active volcanoes, many are remote, windswept and difficult to reach. Around them, the weather changes quickly, currents move strongly through gaps, and fog can make even a nearby island seem like a rumour. The islands matter because they separate two very different bodies of water. On one side lies the Sea of Okhotsk, cold, partly enclosed, seasonally icy, and shaped by continental weather. On the other side lies the Pacific, vast, deep and full of energy arriving from long distances. The straits between the Kuriles allow water to move between these worlds. That movement is not just a gentle exchange, like someone opening a window to let in fresh air. It can be powerful. Tides push water back and forth. Currents are squeezed through passages. Deep water can rise and mix. Surface waters can be cooled, stirred, or redirected. The geography turns the boundary into a working machine. This is where the phrase gates becomes useful. The Kurile Straits are not gates in the human sense, with hinges and signs and perhaps a small booth where someone asks for paperwork. They are natural gates. They regulate water exchange, shape currents, and create difficult local conditions. A ship passing through them is not merely crossing a line on a chart. It is moving through a zone where sea state, current, visibility and weather can all change in a short distance. The open Pacific may send swell toward the islands. Winds may funnel along channels. Tides may run against waves. Fog may hide land until it is uncomfortably close. The straits are openings, but openings can be dangerous when the world on either side is moving hard. One of the reasons these passages are so complex is that the seafloor is not smooth. Around volcanic island chains, the underwater landscape can include ridges, slopes, basins, shelves, and sudden changes in depth. Water moving across uneven bottom terrain behaves differently from water moving over a flat plain. It can accelerate, swirl, rise, sink, and mix. To an oceanographer, this is fascinating. To someone trying to navigate safely in poor weather, it may be fascinating later, after arrival, when dry socks have been located. The Kurils also mark one of the great tectonic boundaries of the Pacific. Beneath and near these islands, the Pacific plate is moving northwestward and diving beneath the Okhotsk microplate along a subduction zone. That sentence is tidy, but the process is immense. A slab of oceanic crust, cold, dense and heavy, is being forced down into the mantle beneath another piece of Earth's outer shell. It moves slowly by human standards, only centimetres per year, but geological slowness should not be mistaken for weakness. Over years, decades and centuries, stress builds along parts of the plate boundary. Rock bends, friction holds. Then, in an earthquake, a locked section can suddenly slip. This is the restless earth below the sea. It is not restless in the way a person taps a foot during a long meeting. It is restless in a deeper and more patient way. Most days, nothing dramatic happens at the surface. Waves move, fog comes and goes, ships pass, birds circle, fish move through cold water. Far below, plates continue pressing against each other. The energy builds invisibly until a rupture releases it. When that happens under the sea, the result can be a large earthquake. If the seafloor moves vertically enough, it can also disturb the water above it and generate a tsunami. Tsunamis are often misunderstood because they do not behave like ordinary wind waves. A storm wave is created by wind blowing across the water surface. It may be steep, breaking, and obvious. A tsunami is usually created by a sudden displacement of water, often from an undersea earthquake, landslide, or volcanic process. In deep water, a tsunami may be low in height, but extremely long from crest to crest, travelling across the ocean at high speed. A ship in deep water might barely notice it. Near shore, as the wave enters shallower water, it slows, rises, and can become destructive. The danger is not only the height of the water, but the force and volume behind it. It is not a normal wave arriving. It is the sea temporarily changing where it believes the coastline should be. The Kuril-Kamchatka region has produced many large earthquakes. This is not a rare geological accident. It is a known seismic zone. Great earthquakes have occurred along this arc, and some have generated damaging tsunamis. The chain of islands and the nearby trench are part of the Pacific Ring of Fire, the broad zone around the Pacific where subduction, earthquakes and volcanoes are common. That does not mean every island is shaking every afternoon, or that sailors are constantly dodging tsunamis between cups of tea. But it does mean the baseline risk is real. The sea's danger does not come only from what the sky is doing, it also comes from what the seafloor might do. This is one of the unsettling facts about the Sea of Okhotsk region. Storms can be forecast, ice can be observed, fog can be measured, earthquakes are different. Scientists can identify hazardous zones, study fault behaviour, measure plate motion, and estimate probabilities, but they cannot predict exactly when a major earthquake will occur. So the geological risk sits in the background, usually quiet, always possible. It is the sort of danger that makes maps feel less flat. A coastline is not just a boundary between land and water. It may also be the edge of a moving plate system. The Kuril Islands themselves owe much of their existence to this subduction. As the Pacific plate descends, water and other materials released from the slab help melt mantle rock above it. That molten rock can rise, feeding volcanoes. Over long periods, eruptions build islands, cones, ridges, and volcanic landscapes. This is why the Kurils are not gentle low sandbars. They are part of a volcanic arc. Some volcanoes are quiet for long periods. Some produce ash, steam, lava, or explosive eruptions. Volcanic activity can affect local communities, aircraft, ships, and the surrounding environment. Ash clouds are especially important for aviation because volcanic ash can damage jet engines. A remote eruption on an island few people can name may still matter to aircraft routes crossing the North Pacific. At sea level, the volcanic character of the islands creates rough coastlines and difficult landing places. Steep slopes, cliffs, and rocky shores are common. Many islands have limited shelter. Weather may make approach difficult. Fog may hide hazards. Surf may pound exposed coasts. Even when the land looks near, it may not offer safety. That is a cruel little trick of rugged islands. They can appear as rescue on the horizon, then reveal themselves as cliffs, rocks, and no usable harbour. The map shows land. The ship asks, yes, but can I safely go there? Very often the answer requires more patience than hope. The deep channels between some Kuril islands are important for the movement of water between the Pacific and the Sea of Okhotsk. These passages allow Pacific water to enter the sea and Okhotsk water to leave. Mixing in the straits can help move heat, salt, oxygen and nutrients. In some places, strong tidal mixing can bring nutrient-rich water upward, supporting marine productivity. This is one reason the region can be rich in life despite its harshness. Cold, stormy and remote does not mean empty. In fact, some of the roughest seas are biologically rich precisely because mixing and seasonal changes feed the base of the food web. But the same mixing that supports life can create navigational complications. Currents through straits may be strong, eddies can form, waves can steepen when currents run against wind or swell. A vessel may experience confused seas, where waves do not arrive neatly from one direction. In poor visibility, these local conditions become even more demanding. The Kuril gates are not merely gaps, they are places where energy passes through. Water energy, wind energy, tidal energy, geological energy, and human movement all meet there. It is a busy threshold in a place that might look empty to anyone flying over cloud. The isolation adds to the risk. Many of the Kuril islands are far from major support centres. Weather can limit access. The population is small compared with more familiar coastal regions. Infrastructure is not evenly distributed. For ships operating nearby, the remoteness changes the meaning of an emergency. If something goes wrong in a busy shipping lane near a major port, help may be relatively close. In the Kurils and the Sea of Okhotsk, distance can stretch every problem. A mechanical failure, medical emergency, grounding, collision, or storm damage may require response over long distances in poor conditions. The sea does not need to create a unique disaster. It can make ordinary trouble harder to solve. The islands have also carried political weight. The southern Kurils, known in Japan as the Northern Territories, have been disputed between Russia and Japan since the end of the Second World War. This political issue is not the main focus of the sea's natural danger, but it is part of the human geography of the region. Borders, claims, military presence, fishing rights, and access all shape how people move through and manage these waters. A remote sea is not necessarily a simple sea. Human history often gathers around narrow passages and island chains because they control routes, resources, and security. The Kurils are no exception. Still, the natural forces came first and remain larger than the political lines drawn over them. The islands existed before modern states, and the plate boundary existed long before islands had names on charts. Earthquakes do not pause at borders, tsunamis do not check passports, ash clouds do not follow diplomatic agreements. The physical reality of the region cuts underneath human arguments and continues regardless of them. This can be a humbling thought, though not necessarily a comforting one. Humans can dispute an island. The volcano under it may decide to contribute its own statement, written in ash. One of the great earthquakes associated with the wider region occurred in 1952 off Kamchatka, generating a destructive Pacific-wide tsunami. Other major events have occurred near the Kurils, including large earthquakes in the 20th and 21st centuries. The 2006 and 2007 Kuril earthquake sequence drew scientific attention because of the way large events occurred in nearby parts of the plate boundary and outer rise region. These events remind us that subduction zones are not simple straight cracks. They are wide, complex systems with stress distributed across different faults and depths. A single rupture can affect the surrounding region, leading to aftershocks and further adjustments. The Earth does not always finish its business in one neat motion. There are also deep earthquakes beneath the Sea of Okhotsk region, including very large deep focus events. Deep earthquakes happen far below the surface, within the descending slab, and they are different from shallow megathrust earthquakes that can generate large tsunamis. They may be felt over huge distances because seismic waves travel efficiently through the Earth. A deep earthquake does not usually produce the same tsunami hazard as a shallow seafloor rupturing earthquake, but it shows how far down the tectonic system remains active. The slab continues into the mantle, and even at great depths it can fracture. The word below becomes almost inadequate. The restless Earth is not just under the seabed, it continues hundreds of kilometres down. For someone trying to understand why the Sea of Okhotsk deserves attention, this layered danger is important. At the surface there is ice. Above the surface there is fog and storm. Around the edges there are narrow straits and rugged islands. Beneath it all, there is a plate boundary capable of large earthquakes and volcanic activity. Any one of these would make a sea worth respecting. Together they create a region where danger is not a single feature, but a stack of conditions. The Sea of Okhotsk is not merely cold. It is cold in a place where the Earth's crust is active, where island gates complicate water movement, and where the Pacific presses against the basin both through water and geology. The human body is not built to sense plate tectonics directly. We can feel wind, we can feel cold, we can see fog and ice, but plates move too slowly and too deeply for ordinary perception. That may be why geological danger feels so strange. A storm looks like a storm. Ice looks like ice. An earthquake fault can be quiet for generations, then suddenly become the most important thing in the world for several minutes. The Kuril arc carries that kind of hidden seriousness. It is easy to sail over deep, tectonic forces without feeling them. It is easy to look at an island and see only rock, grass, snow, or a volcano cone. The long story beneath it is harder to picture. Imagine passing through one of the Kuril Straits in poor weather. The vessel moves carefully between islands that appear and disappear in fog. The water is dark and restless. Swell from the Pacific meets local wind and current. A radar screen shows shapes that the eye cannot confirm. Somewhere below, the seafloor drops and rises in ridges and slopes. Far deeper, the Pacific plate continues its slow descent. None of this may cause immediate trouble. Most passages are completed safely by people who know what they are doing. But the setting itself carries pressure. It asks for attention. It asks that no one mistake a gap in the islands for an easy road. At night, the feeling would be even stronger. The islands may be only blacker shapes against a dark sky, or completely hidden. Lights may be few. The ship's instruments become the main sense organs. Wind shifts. Waves slap and lift. The crew moves through routines built from training and repetition. Below them, the water is part of a basin that freezes in winter, mixes through straits, feeds ecosystems, and sits along a restless margin of the planet. The scene may be ordinary for the crew. That is what experience does. It turns extraordinary environments into places of work. But ordinary work in such a place still rests on layers of risk. This is why the Kurils feel less like a border and more like a threshold. They are where the Sea of Okhotsk meets the open Pacific. They are where cold basin water meets deeper ocean exchange. They are where fog, wind, tide and current are shaped by island passages. They are where volcanoes rise because one plate is diving beneath another. They are where earthquakes can shake the seafloor and tsunamis can begin their long travel. A threshold is not necessarily a place to avoid, it is a place to understand before crossing. And as we move from these island gates back toward the working routes of the sea, the human side of the story begins to sharpen, because people have crossed these waters for exploration, fishing, trade, military movement, science, and industry. They have done so in wooden vessels, steel ships, small boats, ice-capable craft, and modern fleets with radar and satellite communication. Some arrived safely, some were delayed, damaged, or lost. The dangers of the Sea of Okhotsk are not only written in geology and weather, they are also written in the long record of ships, crews, remote ports, and the price of working at the edge of a cold and difficult sea. Human beings have always treated difficult seas with a mixture of caution, need, confidence, and forgetfulness. Caution, because anyone who works on water knows that the surface can change faster than a plan. Need, because fish, trade, fuel, transport, research, and survival have a way of pulling people offshore even when the weather would rather they stayed inside. Confidence, because every successful voyage makes the next one feel a little more possible. And forgetfulness, because the sea's quiet days can make its violent ones seem farther away than they really are. The Sea of Okhotsk has known all of this. It is not an empty northern basin sitting untouched at the edge of the map. It is a working sea. Ships cross it. Fishing vessels spread across its grounds. Cargo moves between ports of the Russian Far East. Oil and gas operations depend on routes, platforms, support vessels, and seasonal planning. Coastguards, research ships, naval vessels, ferries, tugs, icebreakers, and smaller local craft all become part of its human traffic. Some pass safely and routinely. Some are delayed by weather or ice. Some return with damage, and some never return at all. A sea can be dangerous in the obvious moment. When wind is high, waves are breaking, and a crew knows perfectly well that they are in trouble. But another kind of danger begins much earlier, in the distance from help. Isolation changes everything. It changes how fast a rescue can begin. It changes how long survivors may have to wait. It changes the consequences of a broken engine, a failed radio, a snapped tow line, a flooded compartment, or one bad decision made in cold weather. In a crowded harbour, a mistake may become an expensive lesson. In the Sea of Okhotsk, the same mistake can become a fight against time. The ports around this sea are not lined up like convenient service stations along a motorway. Some are important, but they are far apart. Magadan, sitting in Nagieva Bay, has long served as a major port on the northern side. Okhotsk, older and remote, gives the sea its name. On Sakhalin, Korsakov connects island life and regional shipping. In the Kurils, places such as Severo-Kurilsk and Yuzhno-Kurilsk matter for local movement, fishing and access. These names mark human footholds around a very large basin, but between them lie long stretches of coast, mountain, ice, fog and open water. A vessel in trouble may not simply turn toward the nearest easy shelter, because the nearest shelter may be far away, difficult to enter, blocked by ice, exposed to weather, or hidden in fog. This is why ships in the Sea of Okhotsk often operate with a serious awareness of season. Timing is not decorative here. In winter, ice can close routes or make them slow and dangerous. In summer, fog can reduce visibility. During stormy periods, strong winds and heavy seas can make towing, fishing, or deck work dangerous. In transition seasons, conditions may combine in awkward ways. Melting ice may still drift in open water. Cold may remain in the sea while the air warms. Storms may move through while crews are trying to take advantage of a short working window. The calendar is less like a set of neat boxes and more like a series of negotiations with weather. For earlier sailors, those negotiations were much harder. Before modern radar, satellite navigation, weather forecasting, ice charts, and emergency communication, crossing or working in these waters required skill, luck, local knowledge, and patience. Fog could hide land, Ice could trap ships. Storms could drive vessels toward rocks or leave them helpless offshore. Charts improved over time, but this region was never as heavily mapped, settled, or travelled by outsiders as more famous seas. Russian expansion into the Far East, fur trading, exploration, fishing, and later military and industrial activity all increased knowledge of the region, but knowledge did not make the sea gentle. It only helped people understand the terms. The long history of navigation here includes many ordinary voyages that left no famous record. That is true of most maritime history. The successful crossings are often quiet. A fishing vessel leaves port, works the grounds, returns. A cargo vessel moves supplies. A tug completes a tow. A research ship gathers data. A crew complains about the cold, the food, the schedule, or someone's habit of leaving wet gloves in the wrong place, and then life continues. The sea's history is built from thousands of such practical journeys, but the wrecks and disasters remain in memory because they show what happens when the system fails, when weather, distance, human decisions, and mechanical limits meet in the wrong order. One of the best-known modern tragedies in the Sea of Okhotsk was the sinking of the fishing trawler Dalny Vostok in 2015. It was a large freezer trawler, a working ship with more than 100 people on board, operating in cold waters near Kamchatka. Reports at the time said that the vessel sank quickly, with 132 people aboard. Dozens died, and dozens more were rescued by nearby fishing vessels. There were reports that drifting ice may have been involved, and that the ship did not send a distress signal before it went down. Whether one reads those details as a maritime investigator, a sailor, or simply a person imagining cold water in the dark, the result is sobering. The speed of such a sinking is one of the most frightening elements. On land, emergencies often leave some room for movement. A person can run outside, call for help, wait under a roof, or at least stand somewhere solid. At sea, if a vessel loses stability or floods rapidly, the world narrows in minutes. Lifeboats must be reached. Survival suits must be put on. Crew must account for one another. The ship may be listing, rolling, dark, wet, or crowded. Cold water waits below. Training matters. Equipment matters. Leadership matters. But even when people do many things right, the cold can decide the outcome very quickly. Cold water does not behave like a dramatic villain. It does not need to thrash or roar. It simply removes heat from the human body much faster than air. In near-freezing water, a person can lose useful movement quickly. Hands stop working properly. Breathing becomes difficult. Panic becomes harder to control. Hypothermia begins to close in. A life jacket can keep someone afloat, but it cannot make the water warm. A survival suit can buy time, but it must be available, fitted, and put on correctly, and time is often exactly what is missing. In the Sea of Okhotsk, the difference between rescue and loss can be measured in minutes, temperature, and distance. Nearby vessels played a major role in the Dalny Vostok rescue effort. That detail matters because it shows a hard truth of remote waters. The first rescuers are often not helicopters or official ships, but other working vessels already in the area. Fishermen rescue fishermen. Crews turn from their own tasks towards someone else's emergency. In a place like the Sea of Okhotsk, this mutual dependence is not sentimental. It is practical. The sea is too large, the weather too hard, and the distance is too long for anyone to assume that help will arrive instantly from shore. A vessel nearby may be the difference between survival and a cold, empty horizon. Another major disaster, very different in kind but similar in lesson, was the sinking of the Kolskaya drilling rig in 2011. The rig was being towed in the Sea of Okhotsk during severe weather when it capsized and sank. There were 67 people aboard. Only 14 were rescued, while 53 were declared dead or missing. This was not a small fishing boat caught unexpectedly at the edge of a squall. It was a large industrial operation involving a drilling platform, tow vessels, winter conditions, and the high-risk environment of a cold northern sea. It showed that size, machinery and industry do not cancel out the basic forces of weather and water. Towing is one of those maritime tasks that can sound simple until you picture it in rough conditions. One vessel pulls another object through the water. The tow line must hold. The towed object must behave. The weather must stay within limits. The route must be judged carefully. Communication must remain clear. If the towed object is large, awkward, and not designed to move like a ship under its own power, the risks grow. A drilling rig under tow is not a graceful creature. It is equipment being moved through an environment that can change faster than a plan. In rough seas, waves, wind, tow line strain, icing, and stability all become part of the same problem. The Kolskaya disaster is often discussed as an example of the risks of operating industrial equipment in severe northern waters. It is not enough to know that a thing can float. It must be safe for the season, the route, the expected weather, the tow arrangement, and the people aboard. In cold, remote seas, the margin for error can be narrow. A delay in leaving, a decision to continue, a forecast that worsens, a tow line problem, a structural weakness, too many people aboard, or a lack of emergency readiness can all add weight to a situation. One factor may not be fatal. Several together can become a disaster. There is an uncomfortable lesson in these accidents. The sea is dangerous, yes, but danger often becomes disaster when natural hazards meet human pressure. Fishing pressure, economic pressure, schedule pressure, fuel costs, seasonal deadlines, industrial contracts, the need to finish a voyage, reach a port, haul a catch, move a rig, keep a project moving, or avoid losing money. These pressures are not imaginary. They are real, and the people making decisions often face difficult trade-offs. But the sea does not negotiate with deadlines. It does not become less cold because a vessel is behind schedule. It does not lower the waves because equipment is expensive. It does not open the ice because the cargo is needed. Fishing vessels especially live inside this tension. The Sea of Okhotsk is rich in marine resources, and that richness draws fleets into hard waters. Fish and crab support jobs, food supplies, companies, towns, and exports. The work is skilled and demanding. Crews may spend long hours in cold, wet, noisy conditions. They handle heavy gear, slippery decks, machinery, and shifting loads. Fatigue is common. Weather windows matter. A good catch can tempt vessels to work longer or push farther. A delay can cost money. And beneath all of it is the simple fact that the best fishing grounds are not always located in the safest water at the most convenient time of year. The fish, unhelpfully, do not gather according to human comfort. Shipwrecks in such places are rarely the result of one dramatic cause. They are usually chains. A vessel is overloaded, or perhaps not, but carrying a heavy catch. Ice is nearby. Weather changes. A compartment floods. A pump fails or cannot keep up. A crew member notices something too late. A distress call is delayed or impossible. The ship lists, gear shifts, cold water enters, rescue begins, but distance and temperature shorten the available time. Afterward, investigations may identify causes, errors, and failures. Those findings matter. They can improve safety, change rules, and save lives. But for the people aboard, the event did not unfold as a report. It unfolded as noise, movement, cold, and urgency. The price of isolation also falls on rescuers. Search and rescue in the Sea of Okhotsk can mean sending helicopters over long distances, dispatching ships into the same rough weather, coordinating with fishing fleets, and searching in cold water where survival time is limited. Bad weather does not politely stop because an emergency has begun. Ice, wind, fog, and darkness can all interfere with rescue. A helicopter may have range and visibility limits. A ship may need hours to reach the area. Survivors may be scattered. Life rafts may drift. Signals may be weak or absent. The response itself becomes dangerous work. This is why maritime communities often develop a practical respect that outsiders may mistake for calmness. People who work in dangerous seas are not always dramatic when they describe them. They speak in details: ice thickness, wind direction, engine trouble, deck load, barometer reading, radio contact, visibility, fuel, distance to port. They know that danger is not improved by large speeches. It is improved by preparation, maintenance, training, judgment, and sometimes the humility to wait. Waiting is underrated in maritime safety. It can feel like lost time, especially in commercial work, but waiting out bad conditions has saved more lives than many heroic decisions made too late. At the same time, waiting is not always available. A ship may already be at sea, a storm may arrive faster than expected, ice may move across a route, a medical emergency may occur far from port. A vessel may have to decide between several imperfect options. This is where isolation becomes more than geography. It becomes decision pressure. In a remote sea, choices are often made with incomplete information, limited time, and consequences that cannot be fully controlled. That is true in many oceans, but the Sea of Okhotsk adds its own severe conditions to the equation. There is also the issue of communication and perception. For many people far from the region, a disaster in the Sea of Okhotsk may appear briefly in international news, then disappear. The names of the ships may be forgotten. The places may feel distant. The numbers may be read and then replaced by the next headline. But in fishing towns, port offices, families and crews, these events have weight. A lost vessel is not a statistic to those who knew the people aboard. It is absence. It is a berth not filled, a call not answered, a routine broken. The sea's remoteness can make its tragedies seem quieter to the outside world, but they are not quieter to the people affected. The cold also preserves a certain seriousness in memory. Wrecks in warm, busy waters may be visited by divers, studied, photographed, and folded into local stories. Wrecks in the Sea of Okhotsk may lie deep, remote, and hard to reach. Some are not easily surveyed, some are known only through reports, coordinates, and the accounts of survivors. The sea keeps them without display. It does not turn them into tourist sites. It simply holds them somewhere below the moving surface, beneath ice in winter, beneath fog in summer, beneath the same waters that continue to feed fish and carry ships. Still, it would be wrong to describe the human story here only through loss. Most people who work the Sea of Okhotsk are not reckless figures in a disaster tale. They are skilled workers doing hard jobs in a hard place. Captains study conditions, crews maintain vessels. Icebreakers support navigation. Port authorities track movements. Scientists improve understanding. Engineers design for cold, waves and ice. Search and rescue teams train for emergencies they hope never happen. Fishing fleets operate with routines built from experience. The sea's danger is real, but so is human competence. If competence did not exist, no one could work there at all. That competence is part of the region's quiet history. It appears in ordinary, successful returns. In a vessel reaching harbour after a rough passage, in a tow completed before weather worsens, in a crew deciding not to sail, in a radio call answered, in ice reports used properly, in a storm avoided by patience. Maritime safety often looks boring when it works. That is one of its best qualities. A safe voyage produces no dramatic headline, no documentary reenactment, no famous photograph. It produces tired people stepping onto land, cargo unloaded, fish processed, equipment repaired, and perhaps someone finally getting a proper cup of tea. The Sea of Okhotsk demands that kind of competence because it does not forgive carelessness easily. Its dangers are not secret. Ice is expected. Fog is expected. Storms are expected. Distance is expected. Strong currents and submerged rocks are known hazards. But knowing a hazard exists is not the same as being protected from it. A person can know a floor is slippery and still fall. A captain can know a sea is dangerous and still be caught by a chain of events. That is why preparation must be repeated, not merely understood once. Safety at sea is not a thought. It is a habit. As ships continue to cross and work these waters, the price of isolation remains built into the route. Modern equipment has improved survival chances in many ways. Weather forecasting is better. Satellite tracking is better. Emergency beacons are better. Ice monitoring is better. Vessels are stronger and communications more reliable. But the Sea of Okhotsk is still large, cold, foggy, icy, storm-prone and remote. A stronger ship may endure more, but it still has limits. A better forecast may warn of danger, but someone must act on it. A distress signal may travel quickly, but a rescue ship still has to cross the water. This is the practical truth behind the wrecks. They are not only stories of failure, they are reminders of scale. The scale of the sea, the scale of cold, the scale of distance, and the scale of responsibility carried by people who work where help may be far away. The Sea of Okhotsk does not become dangerous only when something goes wrong. It is already demanding before the first line is cast, before the tow begins, before the vessel leaves port. The danger is present in the planning, the loading, the maintenance, the route, the weather check, the crew list, the emergency drill, and the decision to continue or turn back. And while the surface carries these human stories of ships, rescues, wrecks, work, and loss, another story continues below. Beneath the cold water, beneath the ice in winter and the fog in summer, the Sea of Okhotsk is not empty or silent. It is one of the productive cold seas of the world, filled with the movements of plankton, fish, crabs, seals, seabirds and whales. The same conditions that make it hard for humans help feed an entire living system. And that is where the next part of the journey leads, under the frozen surface and into the life that has learned to survive there. Beneath the cold surface of the Sea of Okhotsk, below the ice that drifts and grinds through winter, below the fog that hides the coast in summer, there is a living system that is much busier than the surface suggests. From above, especially in winter, the sea can look almost empty. White ice, grey sky, dark water in cracks and leads, and long distances with little sign of movement. But the absence of easy human comfort is not the same as absence of life. The Sea of Okhotsk is one of the most biologically productive seas in the world, and that productivity begins with conditions that, for humans, often feel harsh, inconvenient, and very good at ruining plans. Cold seas can be rich seas. That may seem surprising at first because many of us associate life with warmth, sunlight, green leaves, and pleasant temperatures. But in the ocean, productivity depends heavily on nutrients, mixing, light, and seasonal timing. Warm tropical water can be beautifully clear because it's often poor in nutrients near the surface. Cold northern water, especially water that is stirred, mixed, and fed by rivers and deep currents, can support enormous blooms of microscopic life. The Sea of Okhotsk is a good example of this. Its cold water, river input, winter mixing, sea ice formation, and exchange through the Kuril Straits all help create conditions where nutrients can reach the sunlit upper layer. Once light returns strongly in spring, small organisms respond quickly. At the base of the food web are phytoplankton, tiny plant-like organisms that drift in the upper water and use sunlight to grow. They are small enough to be overlooked by anyone hoping for dramatic wildlife, but they are the reason much of the drama exists. Without phytoplankton, there is no great chain of feeding above them, no large schools of fish, no heavy nets, no seabirds gathering at the surface, no seals resting on ice after feeding, no whales moving through cold feeding grounds. Phytoplankton do not roar, breach, or look especially good on a poster, but they are doing much of the important work. They are the kitchen staff of the sea, and as usual the kitchen staff deserves more credit. During winter, the upper ocean can be mixed by cold winds and storms. Nutrients from deeper water can be brought upward. Sea ice forms, salt is expelled into the water below, and dense water develops in some regions. The ice also changes the amount of light reaching the water. For months, growth can be limited by darkness and ice cover. Then spring comes. The sun rises higher, the days lengthen, ice begins to thin, break and melt. Fresh melt water can create a lighter surface layer that stays near the top. Nutrients are available, light increases, phytoplankton grow rapidly. This spring bloom is one of the key moments in the yearly life of the sea. It is not loud, but it is one of the main reasons the ecosystem can support so many animals. There is also life connected directly to the ice. Sea ice is not simply frozen water, with nothing going on inside it. Brine channels, tiny spaces, and the underside of the ice can support algae and small organisms. Ice algae can grow where enough light reaches them, especially near the bottom of the ice. When the ice melts, some of this material enters the water and becomes food for other organisms. The ice is therefore both a surface and a habitat. To a ship it may be an obstacle. To certain seals it may be a resting platform or nursery. To small organisms it can be a place to live, feed, hide, or wait for the season to change. The timing of the ice matters. If the ice forms, melts, or retreats at different times, the bloom can shift. If the bloom shifts, the animals that depend on it may be affected. Timing in a cold sea is practical. Tiny crustaceans, fish larvae, seabirds, and marine mammals all depend in different ways on food being available when it is needed. A bloom that comes too early, too late, or in the wrong place can change survival for young animals. The sea's calendar is written in light, ice, and temperature, not in neat boxes on a wall. Living things have adapted to that calendar over long periods, but adaptation does not mean every year is easy. Zooplankton feed on phytoplankton. These are small, drifting animals, including copepods and other forms that may look minor to us, but are essential to the system. Some are eaten by fish larvae. Some are eaten by larger plankton feeding animals. Some become part of the food supply for species such as walleye pollock. In a productive sea, energy moves upward in stages. Sunlight feeds phytoplankton. Phytoplankton feed zooplankton. Zooplankton feeds small fish and young fish. Fish feed larger fish, seabirds, seals, and whales. It is tempting to picture this as a tidy ladder, but it is really a web, with many loops, shortcuts, and messy dining arrangements. Nature has never been known for setting the table neatly. Walleye pollock is one of the most important fish in the Sea of Okhotsk. It is a schooling fish, often found in large numbers, and it supports major fisheries. Pollock are not glamorous in the way whales are glamorous, but in ecological and economic terms they matter enormously. They feed on plankton, small fish and other prey, and they are eaten by larger predators. For humans, they are one of the main commercial species of the northern Pacific region. If you have ever eaten certain kinds of fish sticks, imitation crab, or fast food fish products, there is a fair chance that pollock, or a close part of that fishery world, has entered your life without introducing itself properly. Not every important creature gets a dramatic entrance. The Sea of Okhotsk also supports herring, cod, flatfish, salmon, smelt, capelin and other fish species. Some live in open water, some stay closer to the seafloor, some move between rivers and sea. Salmon are especially tied to the surrounding land because they return to rivers to spawn. This links the marine ecosystem with forests, bears, birds, rivers and coastal communities. A salmon born in a freshwater stream may grow in the sea, return inland, and carry marine nutrients back into the watershed. In that sense, the Sea of Okhotsk does not stop at the shoreline. Its life enters rivers, forests, markets, villages, and the bodies of animals far from the surf. The shallow coastal zones are important too. These areas can serve as spawning and feeding grounds for commercial fish species, as well as habitat for kelp and invertebrates. Kelp forests and seaweed beds may not look dramatic from the surface, but they create structure in the water. They provide shelter, food, and nursery habitat. Crabs, shrimp, mollusks, sea urchins, and other bottom-dwelling animals can gather in productive coastal areas. The seafloor is not a blank floor. It has mud, sand, rock, shell, plants, animals, burrows, hiding places, feeding grounds, and all the slow work of organisms living their lives while humans mostly look at the waves and miss the lower half of the story. Crabs are especially important in the human imagination of this region, because cold northern seas are often associated with valuable crab fisheries. Snow crab, king crab, and other commercially important crabs live in cold waters of the North Pacific and nearby seas. In the Sea of Okhotsk, crab and other shellfish have long been part of the region's fisheries. For the crabs, of course, being valuable to humans is not exactly a blessing. It means nets, pots, regulations, quotas, markets, and a great deal of attention from people in waterproof clothing. Still, their presence shows how productive the bottom habitat can be. Crabs feed, grow, molt, reproduce, and move through a world shaped by temperature, depth, food, and predation. Above them, seabirds use the sea as a feeding ground. Gulls, auklets, murres, cormorants, and other birds may depend on fish and plankton-rich waters. Some nest on cliffs and islands, then travel out to feed. Seabirds are often good indicators of what is happening below the surface because they gather where prey is available. A patch of feeding birds can reveal fish near the surface or plankton concentrated by currents. To a sailor, birds may be part of the scenery. To a biologist, they are clues with wings. To the fish below, they are very much not scenery. Marine mammals also use the Sea of Okhotsk in large numbers. Seals are especially tied to the ice. Ribbon seals, spotted seals, ringed seals, bearded seals, and other northern species are associated with this broader region. And some use drift ice for resting, breeding, molting, or nursing. Ribbon seals are among the most striking, with bold, pale bands on dark fur. They look almost designed by someone who thought ordinary seals needed a more formal outfit. But their lives are not decorative. They depend on seasonal ice and cold water food webs. They feed on fish and invertebrates, rest on ice, and move with the changing conditions of the sea. A seal hauled out on ice may look relaxed, but it is part of a very practical arrangement. Ice provides a platform away from many land-based predators. It can be used for giving birth and nursing young. It gives the animal a place to rest between feeding trips without needing to return to shore. If the ice changes, the available habitat changes. If the ice retreats earlier or becomes less stable, animals that depend on it may need to adjust their behaviour, distribution, or timing. Some may manage better than others. Nature is flexible, but not infinitely flexible, and young animals are often the first to show when conditions no longer match the old pattern. Stellar sea lions also live in the wider region, using coastal haul-outs and feeding in productive waters. They are large, social, noisy animals, which means they bring some needed disorder to otherwise serious coastlines. Sea lions feed on fish and squid, and they depend on healthy prey populations. Like seals, they connect the surface, the shore, and the underwater food web. They are also affected by human activity, including fisheries, disturbance, pollution, and changes in prey availability. A cold, productive sea can support large predators, but only if the food web beneath them remains strong enough. Whales add another scale entirely. The Sea of Okhotsk and nearby waters have supported several whale species, including grey whales, bowhead whales, belugas, minke whales, and others, depending on season and location. Some are regular visitors, some have specific feeding areas, some are rare and closely watched by scientists. Grey whales are particularly notable because the western grey whale population has been one of the most endangered whale populations in the world, with important feeding habitat near Sakhalin. Their presence reminds us that an industrial sea and a wildlife sea can be the same place. A vessel, an oil platform, a whale feeding ground, and a fishing area may all be connected by the same cold water. Whales feed in different ways. Some strain small organisms through baleen. Some feed on fish. Some dive to the bottom and disturb sediment to find small animals. The exact feeding depends on the species, but all of them depend on a functioning food web. Large whales may seem almost separate from the small life below them because they are so physically impressive, but their size is built from tiny things eaten in huge quantities, directly or indirectly. A whale is not just a whale. It is the result of plankton, nutrients, currents, timing, fish, and feeding grounds all working well enough for years. That is a less obvious kind of engineering, but it is very effective. The Sea of Okhotsk's productivity also comes from exchange with the Pacific. Water moving through the Kuril Straits brings and removes heat, salt, nutrients, and organisms. Strong mixing in and near those straits can help bring deep nutrients upward. Rivers bring fresh water and sediments from the surrounding land. Winds and winter cooling mix the upper water. These processes help feed the base of the ecosystem. The sea's harshness and its richness are therefore linked. Cold, wind, ice, and mixing are not separate from life. They are part of how life is supplied. This is one of the main lessons hidden under the ice. What makes the Sea of Okhotsk dangerous for ships can also make it productive for animals. Strong winds mix water. Cold air helps form ice. Ice influences density and seasonal blooms. Straits stir nutrients. Currents gather food in patches. Fog and storms may trouble humans, but the sea's living system has evolved with those patterns. A stormy sea is not automatically a poor sea. Sometimes it is the opposite. It is a sea where energy and nutrients move, where food can be created in sudden abundance, where animals gather because the conditions are hard but useful. Of course, life beneath the frozen surface is not untouched. Fishing pressure can change populations. Climate change can alter ice timing and water temperature. Industrial activity can add noise, traffic, and pollution risk. Shipping can disturb animals. Oil and gas development can create conflict with feeding areas. Bycatch, illegal fishing, and poor management can damage even productive systems. A rich sea can be exhausted if treated carelessly. Productivity is not the same as endlessness. The fact that a sea gives a lot does not mean it can give without limit. This is a lesson humans have had to learn many times, usually after first pretending not to hear it. Still, the resilience of the living system is remarkable. Each year, in the cold and dark, the sea prepares itself. Nutrients build, ice forms, animals wait, move, feed, breed, or migrate. Then light returns, ice retreats, phytoplankton bloom, zooplankton graze, fish grow, birds gather, seals haul out and dive, whales move through feeding grounds. The whole system turns through its seasons with a precision that is not mechanical, but still dependable enough that life has built itself around it. It is not gentle, and it is not guaranteed, but it is real. Imagine drifting in thought beneath a sheet of sea ice. Above, the wind moves over a white surface. A ship far away works carefully through open water. A seal rests near a lead, ready to slip below. Under the ice, faint green-brown algae cling where light can reach. Tiny animals drift. Fish move in schools through cold layers. Crabs walk slowly over the bottom. Somewhere beyond the shelf, deeper water holds its own quiet movements. A whale passes through the region on a feeding route that may be older than any port on the coast. None of this needs to be loud to be alive. From the human side, the Sea of Okhotsk often appears as a difficult workplace, a dangerous route, a resource area, or a remote boundary. From below, it is a layered habitat. Surface ice, open water, deep basins, coastal shelves, kelp zones, river mouths, island straits, mud bottoms, rocky shores, and plankton blooms all fit together. Each layer has animals adapted to its rules. The sea is not one environment, it is many environments stacked and connected. A seal depends on ice, but also on fish. Fish depend on plankton and smaller prey. Plankton depend on light and nutrients. Nutrients depend on mixing, rivers, and water exchange. The chain is not fragile in the sense of being weak, but it is connected in ways that can be disrupted. That connection brings us back toward people, because the same abundance that feeds whales, seals, seabirds and fish also attracts human industry. Fisheries come for pollock, herring, salmon, cod, flatfish, crab and other species. Oil and gas projects come for energy resources beneath or near the sea. Ships come to move supplies and products. Governments come to regulate, claim, defend and study. The living richness of the Sea of Okhotsk is not separate from its human story. It is the reason so many people are willing to work in cold, fog, ice and storms. The sea is dangerous, but it is also valuable, and that combination has always been enough to pull humans back onto the water. The abundance beneath the Sea of Okhotsk has always created a problem for human beings. Not because abundance is bad, of course. A rich sea feeds people, supports towns, fills markets, supplies work, and gives coastal communities a reason to keep going through winters that would make a houseplant file a formal complaint. The problem is that abundance invites hunger, not only the simple hunger of a person needing food, but the larger human hunger for profit, fuel, exports, development, security, growth, and control. Once a sea is known to be rich, it becomes harder to leave it alone. The Sea of Okhotsk is not rich in only one way. It holds fish, crabs, shellfish, marine mammals, seabirds, and the cold productive waters that support them. It also lies beside Sakhalin, where major offshore oil and gas projects have turned the eastern edge of the island into one of the most important energy regions in Russia's Far East. So the sea is pulled in two directions at once. From below, it offers living resources that reproduce, migrate, feed, and depend on seasonal balance. From beneath the seabed and the surrounding offshore fields, it offers fossil fuels formed over deep time, resources that humans extract with platforms, wells, pipelines, tankers, and long chains of industry. In both cases, people come because something valuable is there, and in both cases the sea adds a warning in small print, usually written in ice, fog and waves. Fishing is the older hunger. Long before offshore platforms and liquefied natural gas, people came to these waters for food. Fish were not just products, they were survival, trade and settlement. Coastal life around northern seas has often depended on timing, when fish return, when ice opens, when storms allow boats out, when rivers carry salmon, when winter stores need filling. The Sea of Okhotsk's cold productivity made it an important fishing region because the food web below the surface could support large populations of commercially valuable species. Walleye pollock, herring, cod, flatfish, salmon and crab became part of the region's economy. Some species stayed mostly offshore. Some connected sea and river. Some moved in schools so large that fishing fleets could build entire seasons around them. Walleye pollock is especially important. It is one of those fish that rarely receives public admiration, but quietly appears everywhere in the human food system. It can become filis, frozen products, processed fish, and surimi, the paste often used to make imitation crab. It is not the kind of creature people usually put on a poster beside a sunset, but it has supported huge commercial fisheries across the North Pacific. In the Sea of Okhotsk, pollock is part of a wider system of feeding and being fed upon. It eats smaller organisms and is eaten by larger predators. For humans, it becomes tonnage, quotas, supply chains, processing plants, exports, and dinner. That is a lot to place on a fish that probably did not ask to become an economic category. Salmon tell a different story because they cross the boundary between saltwater and freshwater. They grow in the ocean, then return to rivers to spawn, bringing marine nutrients back inland. Around the Sea of Okhotsk, this matters for coastal communities, fisheries, and ecosystems. Salmon are not just fish in the sea, They are links between mountains, forests, bears, birds, rivers, boats, markets, and families. A salmon's life is a journey through several worlds, and humans have learned to wait along those routes. We build nets, processing facilities, canneries, rules, arguments, celebrations, and, occasionally, very confident opinions about the best way to cook them. The salmon, meanwhile, continue the old work of returning, if we allow enough of them to do so. Crabs add another layer to the human appetite. Cold northern crab fisheries can be extremely valuable, which means they attract skill, investment, regulation, and illegal activity when oversight fails. Crab fishing is demanding in any cold sea. Gear is heavy, decks are wet, weather can shift, and the animals themselves live where they live, not where it would be convenient for humans to retrieve them. The value of crab can make the work worth the risk, but value can also increase pressure. When a species becomes profitable, people may fish harder, push seasons, compete for grounds, or search for ways around limits. That is not unique to the Sea of Okhotsk. It is a human pattern found across the world's oceans. When something in the water becomes valuable, someone eventually tries to take too much of it. This is why fisheries management matters so much. A productive sea can seem endless when catches are good, but no fishery is endless if reproduction cannot keep pace with removal. Rules about quotas, gear, seasons, protected areas, bycatch, vessel monitoring and enforcement are not bureaucratic decoration. They are attempts to keep hunger from eating the future. Sometimes they work well, sometimes they are weakened by poor data, corruption, illegal fishing, economic pressure or political conflict. Managing a cold remote fishery is especially difficult because the sea is large, the weather is harsh, and monitoring every vessel across every fishing ground is not simple. A regulation written in an office still has to survive contact with fog, ice, distance, money and human creativity. Illegal, unreported and unregulated fishing has been a concern in many parts of the North Pacific, including waters connected to Russian fisheries. It can include underreporting catch, fishing in closed areas, mislabeling products, or exceeding limits. The details vary by species and region, but the basic problem is clear. If fish are removed without proper accounting, managers cannot know how much pressure the population is under. Legal fishers are also harmed because they follow rules, while others profit by ignoring them. The sea itself cannot file paperwork about missing fish. It shows the consequences later through declining stocks, smaller catches, damaged habitats, or disrupted food webs. The Sea of Okhotsk is important not only because of the amount of fish taken from it, but because fishing there affects many parts of the ecosystem. Pollock, herring, salmon and other species are food for larger animals. If humans remove too much, predators may struggle. If fishing gear damages the seafloor, bottom habitats can be changed. If bycatch kills non-target species, the cost of fishing becomes wider than the market price suggests. A fish fillet in a freezer case looks simple. Behind it may be a vessel, a crew, a quota, a weather window, a processing plant, an export route, a stock assessment, a fuel bill, and a question about how much the sea can give without being diminished. There is a soft temptation to divide human use into good and bad, as if fishing were only noble or only destructive. The truth is more practical. People need food. Fishing supports livelihoods. Fish can be a lower impact protein than many land-based alternatives when managed well. Coastal communities have cultural and economic ties to the sea that cannot be dismissed from a distance. At the same time, overfishing, waste, illegal catch, and habitat damage are real. The same net can mean dinner, wages, pressure and risk. The same vessel can represent skill and strain. The question is not whether humans should use the sea at all. Humans are part of the world and have always used it. The question is whether we can take without pretending that taking has no cost. Oil and gas make that question sharper. Off Sakhalin Island, the Sea of Okhotsk is not only a fishing ground and marine habitat, it is also an energy frontier. Projects such as Sakhalin 2 developed offshore fields in the Sea of Okhotsk, including the Piltun-Astokskoye oil field and the Lunskoye gas field. Platforms, pipelines, shore facilities, export terminals, tankers, supply vessels, ice management, and emergency planning all became part of the coastal and offshore landscape. This is not a small industrial footprint. It is a major effort to extract energy in a region where the sea freezes, storms build, fog arrives, and earthquakes are part of the broader setting. A warm, quiet, shallow bay would be easier, but energy resources rarely arrange themselves for human convenience. The engineering challenge is serious. Offshore structures in this region must be designed for ice, waves, cold, and seismic risk. Ice can push against platforms. Drifting floes can threaten vessels and equipment. Low temperatures affect materials, machinery, and human labour. Storms interrupt operations. Fog complicates transport. Earthquake risk influences design. Even routine movement of personnel and supplies requires planning. The industrial presence around Sakhalin is therefore a reminder of how far humans will go to obtain energy. We do not merely drill where it is easy. We drill where the resource is valuable enough to justify solving difficult problems, and then we build systems around those solutions. There is a certain brilliance in that. Human engineering can be remarkable. Ice-class platforms, extended-reach drilling, subsea pipelines, liquefied natural gas plants, and specialised vessels represent decades of knowledge and labour. People have learned how to build and operate in environments that would have been nearly impossible for earlier generations. But brilliance is not the same as harmlessness. Every industrial system carries risk. Oil spills, gas leaks, ship accidents, noise, construction disturbance, seabed disruption, and routine pollution all matter more in a cold, productive, and biologically sensitive sea. Cold water can slow natural breakdown processes. Ice can complicate spill response. Remote conditions can delay emergency action. A spill under or near ice is not the same problem as a spill in warm open water, near a large response base. One of the most sensitive issues near Sakhalin has been the presence of western grey whales. These whales have used feeding grounds off northeastern Sakhalin in areas that overlap with or sit near oil and gas development. For whales, feeding grounds are not casual dining options. They are energy banks. A whale must find enough food during the feeding season to support migration, reproduction, and survival. Disturbance from noise, vessel traffic, construction, or habitat change can matter if it affects feeding behaviour or causes animals to leave important areas. A whale cannot simply order delivery from another bay. If a feeding ground is important, losing access to it can have consequences. Industrial development also affects people who depend on living resources. Fishing communities may worry about exclusion zones, pollution, vessel traffic, and impacts on fish behaviour or habitat. Energy companies may argue that projects provide jobs, infrastructure, tax revenue, and fuel. Governments may weigh national energy needs, export income, regional development, environmental protection, and political strategy. Scientists may call for monitoring, mitigation, and caution. Local people may hold several views at once because life is rarely tidy. A person may want jobs and clean water, energy income and healthy fish stocks, modern infrastructure and protection for traditional livelihoods. The conflict is not always between people who care and people who do not. Often it is between needs that are all real. The human hunger for the Sea of Okhotsk therefore has many faces. There is the hunger for food, visible in fishing fleets and processing plants. There is the hunger for energy, visible in platforms and pipelines. There is the hunger for money, visible in export statistics and investment. There is the hunger for security, visible in state control over routes, resources, and ports. There is also the hunger for knowledge, visible in research ships, oceanographic surveys, ice studies, and ecological monitoring. Not all hunger is destructive. Curiosity can be a form of hunger too, though it usually wears a softer coat and carries a notebook. But every form of hunger needs limits. Without limits, a rich sea becomes a mined-out sea, a noisy sea, a depleted sea, or a sea where the living system continues only in fragments. The difficult part is that limits are often felt immediately by humans and only gradually by ecosystems. A closed fishing area may hurt a fleet now. A reduced quota may affect income now. A delayed industrial project may cost money now. But ecological damage may unfold slowly, then become expensive or impossible to reverse. Humans are good at noticing present inconvenience. We are less good at respecting future absence. The fish not born next year do not complain at the meeting. The whale that avoids a feeding ground does not send an email. The crab population that declines quietly does not hold a press conference, though perhaps it should. The Sea of Okhotsk makes these choices more difficult because everything is expensive there. Operating costs are high. Weather delays are common. Safety measures are necessary. Monitoring is harder. Response planning is more complex. This can create pressure to get as much value as possible during workable seasons. A fishing vessel may have a limited window. An offshore project may need to complete tasks before ice returns. A port may need supplies moved before winter closes in. The environment sets deadlines, and human economics adds more. The result is a region where careful management is not only desirable but essential. There is also a global connection. Fish caught in cold northern seas may be processed elsewhere, sold under different labels, or eaten by people who have never heard of the Sea of Okhotsk. Gas from Sakhalin has been part of energy trade in East Asia. Markets far away can influence decisions made near remote coasts. A consumer buying seafood in a city does not see the fog, the ice, the stock assessment, or the vessel that caught it. A household using energy does not see the offshore platform or the whale feeding ground nearby. Modern life separates appetite from place. That separation is comfortable, but it can make responsibility harder to feel. A more honest view keeps the place attached to the product. Fish comes from somewhere. Fuel comes from somewhere. The Sea of Okhotsk is one of those somewheres. It is not just a name in a supply chain. It is a cold, dangerous living sea with storms, ice, animals, workers, and communities. When we understand that, the products become less abstract. A piece of fish is connected to plankton blooms, quotas, deck labour, and weather. A shipment of gas is connected to offshore engineering, ice management, marine habitat, and political decisions. The sea becomes visible again, which is perhaps the first step toward using it with more care. This does not mean the Sea of Okhotsk should be imagined as a museum sealed behind glass. People live around it. People work there. People depend on it. The aim is not to pretend humans can float above nature without touching it. We cannot. The aim is to recognize that taking from a difficult sea requires humility. The same water that feeds economies can punish carelessness. The same ice that helps build productivity can threaten a platform. The same fishing grounds that fill holds also feed seals, seabirds, and whales. The same remote distance that protects parts of the sea from casual tourism can make accidents harder to manage. Everything is connected, but not in a vague way. Connected through food, fuel, labour, money, temperature, current, and consequence. So the human hunger for the Sea of Okhotsk is understandable. A hungry world looks at a rich sea and sees opportunity. Coastal communities see work, companies see resources, governments see strategy, scientists see questions, predators see food. The sea itself offers no opinion, at least not in words. It responds through changes in stocks, ice, habitat, water quality, and weather damage. It gives signals, but humans must choose whether to read them before they become warnings too large to ignore. And this brings us back to the central question that has been waiting under every part of the journey. Why is this sea so dangerous? Not simply because it has ice, or fog, or storms, or earthquakes, or wrecks, or industrial risk, or remote fishing grounds. Many seas have some of these things. The Sea of Okhotsk is dangerous because so many pressures meet in one place. Natural forces, biological richness, human ambition, isolation, cold and economic need all overlap. To understand its danger properly, we have to gather those pieces together and look at the whole system at once. By now, the danger of the Sea of Okhotsk no longer comes from one single feature. It is not only the ice, though the ice can be enough. It is not only the fog, though fog has a quiet talent for making even careful navigation feel like walking through a room with the lights off. It is not only the storms or the remote ports or the narrow passages between volcanic islands or the earthquakes that happen along the restless edge of the Pacific. The real danger comes from the way all of these things overlap. The Sea of Okhotsk is not a place with one problem. It is a place where many problems can arrive together, and once they do, each one makes the others harder to manage. That is what separates a difficult sea from a truly dangerous one. A ship can handle cold if the water is calm and help is nearby. A crew can handle fog if the vessel is well equipped, traffic is light, and everyone has time to move slowly. A fishing fleet can handle rough weather if the forecast is reliable and there is room to run for shelter. A coast can handle isolation if the seasons are gentle and the route is predictable. But in the Sea of Okhotsk, the cold may come with ice. The ice may come with wind. The wind may come with snow. The snow may come with poor visibility. Poor visibility may come when currents are moving through narrow straits, and the nearest safe harbour may be far enough away that every decision starts to matter more. One of the simplest reasons this sea is dangerous is temperature. Cold is not dramatic at first glance, but it changes the rules of survival. Cold air affects machinery, ropes, fuel systems, exposed skin, batteries, metal, and judgment. Cold water is even more serious. A person falling into near-freezing water does not have the long survival window many people imagine from watching films where everyone has time for a full conversation before rescue. Cold shock can make breathing difficult almost immediately. Hands can lose strength. Swimming becomes harder. Even if a person stays afloat, body heat drains quickly. In a warm sea, a life jacket can buy a great deal of time. In the Sea of Okhotsk, a life jacket is still essential, but the water itself starts counting down. The cold also makes work more difficult before anything goes wrong. A crew member on deck in freezing spray is not working in ordinary discomfort. Gloves stiffen. Surfaces become slippery. Metal can be painful to touch. Tasks that would be simple in a harbour become slower and more dangerous. A latch freezes. A line becomes hard. A net gains ice. A walkway becomes slick. The body uses energy just to stay warm, and tired people make mistakes more easily. This is not because they are careless. It is because cold takes attention and strength from everything else. On a working vessel, where timing and coordination already matter, that extra burden can be serious. Ice adds another layer. Sea ice can block routes, damage ships, trap vessels, and change position with wind and current. It does not need to cover the entire sea to be dangerous. Broken ice can still threaten hulls and equipment. Ice pushed together by wind can become thicker and harder to pass. A lead of open water can close. A harbour that was usable can become difficult. A vessel trying to avoid one ice field may be pushed toward rougher water or a less favourable route. The danger is not simply that ice exists. The danger is that it moves, changes, and forces choices. At sea, being forced into fewer choices is often where trouble begins. Then there is fog, which is dangerous in a completely different way. Ice is physical. Fog is informational. It removes what the eye wants most: distance, shoreline, other vessels, and the horizon. Modern radar, GPS, electronic charts, AIS, and communication systems help enormously, but they do not make fog irrelevant. Small vessels may not be easy to detect. Equipment can fail. Human interpretation can be wrong. Fishing gear may be in the water. Rocks and coasts still exist even when they cannot be seen. Fog slows everything down, and in a region where weather windows can already be narrow, slowing down can create its own pressure. Fog also creates fatigue. A crew standing watch in clear weather can compare instruments with what the eye sees. In fog, the mind has to work harder with less confirmation. Every sound seems more important. Every contact on a screen demands attention. The world shrinks to a grey circle around the ship. That can be manageable for an hour. It is harder after several hours, especially if the vessel is working, fishing, approaching land, or moving through traffic. A quiet hazard can still wear people down. Fog does not have to frighten anyone to make them tired, and tiredness has caused plenty of mistakes at sea. Storms are the louder part of the danger, but even storms in the Sea of Okhotsk are not just one thing. Wind raises waves. Waves create spray. Spray can freeze. Freezing spray adds weight high on the vessel. Added weight can affect stability. Strong wind can push ice, shift gear, strain tow lines, and force course changes. Heavy seas can make engines work harder and make deck operations unsafe. Snow or rain can cut visibility. The vessel rolls, pitches, vibrates and pounds, while every person aboard has to keep functioning. A storm becomes dangerous not only because of its strength, but because of the chain of secondary problems it creates. This is why freezing spray deserves special attention. It sounds almost harmless, like a weather detail added to a forecast. In practice, it can become one of the most dangerous cold sea hazards. As seawater lands on a vessel and freezes, ice builds on railings, decks, masts, gear, lifeboats and superstructure. That ice is weight, and weight in the wrong place can threaten stability. The crew may need to remove it with tools, often in the same wind and wave conditions causing the icing. Imagine being asked to chip ice from a moving steel structure in freezing wind while the floor tilts under your boots. It is the kind of task that makes an office printer jam seem like a restful puzzle. The shape of the sea also matters. The Sea of Okhotsk is partly enclosed, surrounded by the Russian mainland, Sakhalin, Kamchatka, Hokkaido, and the Kuril Islands. That makes it different from open ocean. Weather and currents are shaped by the boundaries around it. Water moves through straits rather than through one broad opening. The Kuril passages connect it with the Pacific, but they also create complicated areas where tides, currents, depth changes, swell, wind, and fog can meet. A simple map may show a route. The actual sea may add current on the bow, fog in the channel, swell from the Pacific, and a nearby island hidden until it is much closer than anyone would like. The Kuril Islands also bring geological danger into the picture. This region sits along an active subduction zone where large earthquakes can and do occur. Earthquakes are different from storms because they do not announce themselves in the same practical way. You can watch a low-pressure system approach on a forecast. You can track sea ice by satellite. You can see fog forming, but a major earthquake along a plate boundary can happen without the kind of warning that allows a ship or coastal town to simply move out of the way. If the seafloor is displaced, a tsunami can follow. That possibility adds a deeper kind of risk to a region already difficult at the surface. Volcanoes are part of the same restless setting. The Kuril chain is volcanic, and volcanic islands create rugged coasts, steep underwater slopes, ash hazards, and limited shelter. Not every volcano is active every day, of course. Most days a volcanic island is just land with a complicated history. But the presence of active volcanism matters for aviation, shipping, local communities, and emergency planning. Ash can affect aircraft. Eruptions can disturb nearby waters and coastlines. The islands themselves often have few easy landing places. In bad weather, land may be near but not useful. That is a very specific kind of frustration at sea. Seeing the place where solid ground begins and still not being able to use it safely. Isolation turns all of these hazards into larger problems. A dangerous sea near a large rescue base is one thing. A dangerous sea with long distances between ports is another. Around the Sea of Okhotsk, many areas are remote, sparsely populated, and difficult to reach. Weather may delay rescue vessels or aircraft. Ice may slow response. Fog may limit visibility. Survivors in cold water may not have much time. A ship with engine trouble may drift toward ice or shore before help can arrive. A small problem can grow while everyone is still trying to get to it. Distance does not look frightening on a map, but in an emergency, distance becomes one of the most important facts in the world. This is why the Sea of Okhotsk is not only dangerous to small boats. Large vessels and industrial equipment can also be vulnerable. Size helps, but it does not remove risk. A large fishing trawler can lose stability. A tow can fail. A platform or rig can be caught in conditions that exceed what people expected or planned for. A cargo vessel can suffer mechanical problems. A ship with a trained crew can still face a chain of events too fast or too complex to control. The sea is not impressed by tonnage alone. A larger vessel may have more tools, but it also has more systems that must work correctly. Human pressure is another reason the region is dangerous. People do not usually enter the Sea of Okhotsk for leisure. They go there to work. Fishing vessels go because the sea is productive. Industrial vessels go because oil and gas resources are valuable. Cargo vessels go because supplies and products must move. Research vessels go because the region matters scientifically. Military and patrol vessels go because the area matters strategically. Work creates deadlines, and deadlines create pressure. A captain may know the weather is worsening, but the catch is valuable. A company may know a season is closing, but the project must continue. A port may need supplies before ice returns. These pressures do not automatically cause bad decisions, but they make good decisions harder. This does not mean the people who work there are reckless. Often the opposite is true. They may be highly skilled, experienced, and careful. But dangerous systems can defeat careful people when enough factors combine. A forecast is slightly wrong. Ice moves faster than expected. Equipment fails at the wrong time. A crew is fatigued. A vessel is overloaded or unevenly loaded. A distress call is delayed. A rescue vessel is too far away. None of these alone has to be fatal. Together, they can become the reason a voyage appears later in an accident report. The Sea of Okhotsk is dangerous because it is good at turning combinations into consequences. The richness of the sea also increases exposure. If there were nothing valuable here, fewer people would risk the conditions. But the Sea of Okhotsk is productive. It supports major fisheries. It contains important marine habitats. It borders offshore energy developments. The danger is not enough to keep humans away because the reward is too large. This pattern appears throughout maritime history. People cross dangerous water because there is food, money, trade, fuel, land, or knowledge on the other side. The Sea of Okhotsk is not an exception. It is a clear example. It says, in effect, there is wealth here, but you will not take it casually. Environmental change may also make some risks less predictable. Sea ice varies from year to year, and changing ice conditions can alter navigation, habitats, and wave exposure. Less ice in one area may sound helpful for shipping, but it can mean more open water for waves to build, more coastal exposure, or changes in animal behaviour. More open water does not always mean safer water. It depends on wind, season, route, vessel type, and local conditions. A changing system can be difficult because old experience remains valuable, but may no longer be enough on its own. The rules do not vanish, but some of them shift. The danger also extends to the living system. A sea can be dangerous for humans while also being vulnerable to humans. That sounds contradictory, but it is common. The same environment that can sink a vessel may still be damaged by overfishing, pollution, noise, oil spills, and poorly managed development. A cold, productive sea is not invincible. If a spill occurs in icy conditions, response can be difficult. If fishing pressure becomes too high, stocks can decline. If noise or traffic disrupts whales in feeding areas, the effects may spread through an already stressed population. The Sea of Okhotsk is strong in some ways and sensitive in others, like many real places once the slogans are put away. There is also a psychological danger in unfamiliarity. Famous dangerous seas have reputations that travel ahead of them. Sailors, travellers, and even ordinary listeners may already know to respect the North Atlantic, the Southern Ocean, or the Bering Sea. The Sea of Okhotsk is less widely known. That can make its danger feel surprising. A hidden sea does not benefit from public imagination. People may underestimate it simply because they have not heard its name often. But a sea does not become safer because it is less famous. It only becomes easier to ignore from far away. If we gather the dangers together, the picture becomes clear. The Sea of Okhotsk is cold enough to form extensive seasonal ice. It is foggy enough to hinder navigation during warmer months. It is stormy enough to produce heavy seas, freezing spray, and dangerous working conditions. It has strong currents and difficult passages near the Kuril Islands. It sits beside one of the most active earthquake and volcanic regions on Earth. It is remote with long distances between help and hazard. It is economically valuable, which draws ships, crews, platforms and fishing fleets into the risk. And it is environmentally important, which means accidents and overuse do not only affect humans, but the larger living system beneath them. A less careful person might ask why anyone goes there at all. The answer is simple, because the sea matters. It provides fish, it supports communities, it holds energy resources, it connects regions, it offers scientific knowledge, it contains wildlife and ecosystems that are important far beyond their remoteness. Humans rarely avoid difficult places simply because they are difficult. We learn them, map them, work them, argue over them, profit from them, and sometimes suffer from them. The Sea of Okhotsk is dangerous, but it is not useless. Its danger and its value are tied together. Respect, then, is the main lesson. Not fear in the dramatic sense, not the kind that freezes action or turns a place into a monster, but practical respect. Respect means checking the forecast and believing it. Respect means understanding ice as a moving force, not a white background. Respect means treating fog as a real hazard, not an inconvenience. Respect means designing platforms and vessels for the conditions that exist, not the conditions that would be cheaper. Respect means managing fisheries so that abundance does not become memory. Respect means remembering that rescue takes time, that cold water gives little time, and that the sea will not soften itself because humans are busy. From the safety of a quiet room, it can be strangely calming to see the whole pattern. The Sea of Okhotsk is not dangerous because of a mystery we cannot understand. It is dangerous because of concrete conditions arranged in a severe way. Cold, ice, fog, storm, current, geology, distance, industry, and hunger. Each part can be studied. Each part can be planned for. None can be dismissed. The sea is not unknowable. It is simply demanding. And demanding places have a way of revealing the difference between confidence and preparation. So when someone calls the Sea of Okhotsk one of the most dangerous seas most people have never heard of, the claim is not only about waves or wrecks. It is about a whole region where nature and human ambition meet under hard conditions. It is about a sea that can look empty while supporting enormous life, look frozen while remaining active below, look remote while feeding global markets, and look quiet while sitting along a restless edge of the earth. It is a sea of layers, and every layer asks for attention. And after all this talk of danger, the last thing to remember is that danger is not the only truth of the place. The Sea of Okhotsk is also a sea of work, migration, feeding, freezing, thawing, and returning. It is not waiting for disaster every moment. Most days it simply continues. Ice drifts, fog lifts, storms pass, fish move, crabs walk over the bottom, seals rest on floes, whales feed along cold shelves, ships leave port and return. The danger remains, but so does the ordinary persistence of life around it. That is where the journey begins to soften, not because the sea becomes gentle, but because understanding it gives its harshness a shape we can hold in the mind as we drift toward the end. Now we have reached the quieter end of our journey across the Sea of Okhotsk, though the sea itself is not ending anything. It is still out there, above Japan and beside Russia, held between Sakhalin, Kamchatka, Hokkaido, and the long line of the Kuril Islands. While we sit safely away from its wind, it continues its usual work. Water moves through straits. Ice forms or melts depending on the season. Fog gathers when warm air passes over cold water. Fishing vessels prepare, travel, wait, or return. Seals rest where the ice allows. Whales feed where the food is thick enough. Storm systems move across weather maps before becoming real wind over real water. A place like this can feel distant enough to be almost imaginary, especially if you are listening from a warm room, a quiet street, a city far inland, or a bed where the only waves nearby are the folds of a blanket. But the Sea of Okhotsk is not imaginary. It is a large, working, dangerous, living sea. It has ports, fishing grounds, oil and gas projects, rescue crews, weather stations, ice reports, research vessels, remote settlements, and animals following seasonal routes that do not care whether humans remember the name of the water. It may not be famous in the easy way other seas are famous, but it does not need fame to matter. We began by trying to place it on the map, because many dangers become clearer once the shape of a place is understood. The Sea of Okhotsk is partly enclosed, not fully open to the Pacific, but not separate from it either. The Russian mainland presses along its north and west. Sakhalin stands along one side. Kamchatka rises on the east. The Kuril Islands form a broken boundary to the south and southeast, with the Pacific beyond them. It is not just a blank area of blue. It is a basin with gates, shelves, deep water, river influence, cold air, and long distances between safety and trouble. That geography is the beginning of almost everything that follows. Then came the ice. In winter, the sea changes form. Cold air moves from the continent across the water, pulling heat from the surface until ice begins to spread. Not a little frost along the edges, but broad fields of seasonal sea ice that can alter navigation, support wildlife, and change the way the water below behaves. For ships, ice can block routes, damage hulls, trap vessels, and delay entire plans. For animals, ice can be a platform, a nursery, a hunting base, or part of the yearly timing of life. For the ocean itself, ice formation helps create dense water and affects circulation. So the same frozen surface that looks still from far above is actually part of a moving system. When the ice retreats, the sea does not simply become friendly. In warmer months, fog becomes one of its quiet hazards. Fog is not as dramatic as a storm, and it does not have the physical weight of ice, but it removes information. It hides coasts, vessels, rocks, islands, and the horizon. It makes distance uncertain. It asks crews to trust instruments, training, and patience. It turns the sea into a grey space where sound seems closer than it is, and land can disappear while still being dangerously near. For anyone listening from a comfortable place, fog may sound calm. At sea, calm can be misleading. A quiet danger is still danger. Storms added another layer. Strong winds over cold water can build heavy seas, throw spray across decks, and turn ordinary work into a test of balance and endurance. In freezing conditions, spray can become ice on the vessel itself. Bit by bit, weight builds where it should not. Gear freezes, railings thicken, walkways become slick. People have to work outside in the same conditions, causing the problem. The storm is not one single event. It becomes wind, wave, spray, ice, fatigue, machinery strain, and decision pressure. A dangerous sea often works this way. It does not always defeat people with one blow, Sometimes it simply adds one problem to another until the margin for error becomes very small. Near the Kuril Islands, the danger reaches down into the earth. Those islands are not just a row of remote landforms between the Sea of Okhotsk and the Pacific. They are part of an active volcanic and seismic arc, formed by the movement of tectonic plates. Earthquakes can occur in this region, and some undersea earthquakes can generate tsunamis. Volcanoes rise from the same broad process, adding rugged coastlines, ash hazards, and difficult approaches. Above the surface there may be fog and wind. At the surface there may be rough water and strong currents. Below the surface, there is the slow pressure of the planet itself. That is a lot for one edge of the map to carry, but the Earth has never been shy about working on several projects at once. Then we turn towards ships and wrecks, because the Sea of Okhotsk is not dangerous only in theory. People work there, people cross it, people fish it, supply it, study it, patrol it, and build around it. Some voyages are routine, many are successful. Most do not become stories because safe arrivals rarely make history. But the disasters that do happen remind us what isolation means. In cold water, help may be far away. Weather may delay rescue. Ice may block movement. Fog may limit visibility. A distress call may not come in time. Survival in freezing water is not a matter of bravery alone. It is a matter of minutes, equipment, training, location, and luck. The sea does not become less cold because people are strong. We also looked beneath the surface, where the Sea of Okhotsk changes from a dangerous workplace into a rich living system. Cold water, seasonal ice, mixing, river influence, and nutrient movement help feed plankton. Plankton feeds small animals. Small animals feed fish. Fish feed larger fish, seabirds, seals, sea lions, and whales. Crabs move across the bottom. Salmon link the sea to rivers and forests. Whales use feeding grounds where food is concentrated. The same conditions that trouble ships can support life in great abundance. That is one of the important truths of cold seas. Harsh for humans does not mean empty for nature. And of course, where there is abundance, people come. Fisheries have long pulled humans into the Sea of Okhotsk. Pollock, salmon, herring, cod, flatfish, crab, and other species support work, markets, food systems, and coastal communities. Oil and gas development around Sakhalin adds another layer of human demand, with platforms, pipelines, support vessels, ice management, and environmental concern. The sea provides, but it does not provide without limits. Fish populations can be reduced, habitats can be disturbed, whales can be affected by noise and industrial activity. Oil spills in icy water can be difficult to respond to. A rich sea is not endless just because it is large. That may be the clearest lesson from the whole journey. The Sea of Okhotsk is dangerous because its risks overlap, and it is important because its values overlap too. It is a sea of ice and fish, fog and industry, storms and whales, remote ports and active faults. Its danger is not only natural, and its value is not only economic. It is both a workplace and a habitat, both a route and a barrier, both a source of food and a place where food webs need protection. It asks different things from different people. To a captain, it asks for caution. To a fisher, endurance. To a scientist, attention. To a government, responsibility. To an animal, adaptation. To the rest of us, perhaps only the willingness to notice. There is something useful about noticing a place most people do not talk about. It reminds us that the world is larger than the familiar names. Not every important sea is printed on tourist posters. Not every dangerous coast is part of a famous legend. Some places do their work quietly, far from the usual lights. They feed ecosystems, challenge crews, shape weather, hold resources, and remain mostly outside everyday conversation. The Sea of Okhotsk is one of those places. It waits at the edge of common awareness, not because it is small, but because it is remote, cold, difficult, and tied to parts of the world many people rarely picture. If you are listening at night, there is no need to carry the danger too heavily. We are not standing on an icy deck. We are not waiting for a tow line to hold in rough water. We are not steering through fog between volcanic islands. We are not checking ice reports before leaving port. We are only thinking about the place, placing it carefully in the mind, letting its shape become clear. Sakhalin on one side, Kamchatka on another, the Kuril Islands at the gates, Hokkaido to the south, cold water within, the Pacific beyond, a large northern sea, mostly hidden from ordinary attention, but full of movement, work, and life. It is possible to respect danger without turning it into fear. Fear can make a place seem like a monster, and the Sea of Okhotsk is not a monster. It is a sea. It follows physical rules. Cold air freezes water, wind builds waves, fog forms over cold surfaces, tectonic plates move, fish gather where food exists, people go where resources can be found. When those rules meet in one remote basin, the result is severe. But severity is not malice. The sea is not angry. It is not waiting to punish anyone. It is simply a place where conditions are hard enough that care matters. That is a gentler way to understand dangerous places. They are not always dramatic. They are not always loud. Some of the most dangerous places on Earth are dangerous because they are cold, distant, complex, and practical. A small failure grows because help is far away. A delay becomes serious because the weather is changing. A good catch becomes risky because the deck is icing. A familiar route becomes difficult because fog has covered the coast. A place that looks empty becomes crowded with currents, hazards, animals, and human decisions. The danger is not hidden in a single wave. It is spread through the details, and the details are worth remembering. The Sea of Okhotsk forms large seasonal sea ice despite sitting far south of the high Arctic. Its summer fog can make navigation difficult. Its storms can create heavy seas and freezing spray. Its island gates connect it to the Pacific through passages shaped by currents and rugged seafloor. Its nearby subduction zone can produce large earthquakes and tsunamis. Its fisheries are valuable. Its offshore energy resources are important. Its marine life depends on seasonal productivity that begins with tiny organisms most of us will never see. The more closely we look, the less the sea feels like a blank space. It becomes a system, and systems deserve care. So perhaps this is the right place to return to your own room, your own night, and your own weather outside the window. Maybe it is still raining. Maybe the street is quiet. Maybe there is traffic somewhere in the distance, or a radiator clicking, or a phone glowing a little too brightly near your hand. Far away from all of that, the Sea of Okhotsk continues under its own conditions. If it is winter there, ice may be spreading across the surface. If it is summer, fog may be sitting low over the water. If a storm is moving through, crews may be watching the wind and waiting for the safest choice. If the water is calm, fish may be moving under a surface that gives away very little. Before we finish, I will ask you once more, gently, where are you listening from tonight, and are you near the sea or far from it? If you have ever stood beside cold water, not warm beach water, but serious cold water with a wind coming off it, you may know something of the feeling. It does not invite carelessness. It makes the body pay attention. The Sea of Okhotsk has that feeling on a vast scale. It is a place that says, without needing words, that nature is still large, that distance still matters, and that not every corner of the world has been softened for human comfort. If this quiet journey through ice, fog, storms, ships, fish, oil, whales, and remote coastlines helped you unwind, or helped you learn something about a sea you had never really thought about before, I would be grateful if you liked the video and subscribed. It helps this calm space reach other people who enjoy slow science, distant geography, and the kind of facts that make the world feel wider without making the night feel heavier. And if you know someone who loves maps, cold oceans, hidden places, or dangerous seas, this might be a good one to share with them. Now let the Sea of Okhotsk stay where it is, at the cold edge of the Northwest Pacific. Let the ice drift without you needing to cross it. Let the fog sit over the water without you needing to steer through it. Let the storms pass over the basin while you remain warm and still. Let the whales feed, the fish move, the currents turn through the Kuril gates, and the distant ports keep their lights against the dark. We have visited from a safe distance, learned its shape, listened to its dangers, and seen that even the harshest places are not empty. They are full of work, life, pressure, and meaning. Sleep well wherever you are, near the ocean or far inland, under clear skies or rain. In the early evening or deep into the night, the Sea of Okhotsk will continue its cold, difficult work at the end of the map, and you can drift back now from its frozen edge, leaving the wind outside the story and the water far away.